All right, cool. Let's go ahead and go live right now. Hopefully that works. I'll take a look at the chat and see what people are saying. But here we go. There we go. We are live. Welcome everybody back to Paleontologizing. It is great to have you today. This is take 2 interview with dinosaur paleontologist Jim Kirkland. Somebody who's done 50 years of...
Next spring will be my 50th anniversary hunting dinosaurs on the Colorado Plateau.
Holy cow, 50 years. We're here up at the very top of the Cedar Mountain Formation. Actually, no, not the very top. This is the poison strip.
No, this is the poison strip we're sitting on.
So the mustn't touch it would be higher than this, yeah.
Yeah, and there's no mustn't touch it in the Paradox Basin. So basically, the top of the cliff behind us you can see, and over here, the very rim, that's pretty much the lower Cretaceous, upper Cretaceous contact. And the slope going down to the sands over there is the Ruby Ranch member, lower Ruby Ranch member.
He simply grew spears which projected from his body armor.
Every year. All of these rocks here are considerably older than the classic Deinonychus, Sauropelta beds, Tyrannosaur beds up in the Bighorn Basin that were the first early Cretaceous beds worked in the West. And nothing in this whole bowl is as young as that.
It's all older. That's really cool. Yeah. Shoot, Jim, would you maybe just kind of set the stage? What does planet Earth look like around this time? What do the continents look like? What are the plants doing?
Well, for the base of, like the Jurassic Cretaceous boundary, which is just under our quarry there and at the foot of the big exposure on the south end of this basin, it's a little bit of Jurassic Morrison poking its head up. At that point, during that period, there's a period of mountain building quiescence. So there really wasn't the big mountain building that occurred in the earlier part of the Jurassic or later in the early Cretaceous. So because of that, we end up with, everything kind of rebounds a bit because as the mountains are pushed up, they slowly weight down the surrounding area. But once the mountains, stop doing stuff, they're just eroding down, things actually start coming up again a bit. And we have an interval all the way up the whole side of the Rocky Mountains where between the Jurassic Morrison Formation and the beginning of the Cretaceous is generally a 25 million year gap of sediment bypass. You get some rivers that go across. As we go further west beyond our site, we have a river as big as the Colorado moving boulders, cobble-sized chunks of rock down it. Big old river goes up and enters Wyoming and forms the Pryor conglomerate up there below the Cloverleaf Formation, below those early Cretaceous beds. But that interval actually represents about 25 million years. But in this area, we had underneath our feet 3,000 feet of salt deposited in the late Paleozoic in the Four Deep Basin of the ancestral Rockies on the border of Colorado and Utah. And as those sediments filled in and sea level came up in the late Paleozoic with glacial eustatic changes because they had an ice age in the southern hemisphere, every time the ice sheets melted, the sea level would come up, flood into this basin, then it would come up again, cut it off, turn into salt, and that happened so many times with the cyclothems in the mid-continent that we get 3,000 feet of salt.
Holy cow.
And salt never turns to rock. It's always plastic. So as we piled up rocks, and as you see here, there's over 2 miles of Cretaceous within view here.
Yeah, this is crazy. Let me just kind of pull the camera around a little bit, and let me just turn it so that we can see. There's the Book Cliffs over there, and that's all Manco.
Going all the way across into central Colorado.
Yeah. Over there, and so that's Manco. That is
the slopes are the Mancos group. We have this big bluff in the foreground. That's the Juana Lopez member, and as you cross further west, it correlates into the biggest exposed delta sequence probably in the world. Oil companies all over the planet come here to train their geologists, and the Book Cliffs is a shoreline kind of like the Atlantic Gulf Coast with barrier islands and of course getting hit by hurricanes periodically. But above that, we have late Cretaceous terrestrial rocks. In fact, up in the Book Cliffs, almost due north of us, I'm probably pointing almost perfect to the site, is where this big hadrosaur with incredible skin impressions, that was named Rhino Rex.
Rhino Rex.
The nose king has a big crest on its nose.
Pretty similar to like Gripposaurus, right?
Yeah, and it may properly be in Gripposaurus.
Yeah.
But some kid thought of that as a name for it, and the folks in North Carolina, they're writing it up. It's a Brigham Young University fossil. They basically said, "Oh, we got to use this name."
It's a good name.
So it's like, is it valid? Who knows? It may be.
Yeah.
You know, I mean,
is it
work.
How stratigraphically constrained is that? Like, have they done good strat throughout there?
Yeah, it's. Let's see. I think it's in. I'm trying to remember. It's probably like nearly Caparowitz equivalent.
Okay.
You know, when we go up through the cliffs there, you know, we have two units. And over here, it's called the Farrier facies and the Nielsen facies of the Mesa Verde group. This stuff doesn't even correlate to the type Mesa Verdes. I like to call it the Book Cliffs group. But the lower part is equivalent to the Wahweed Formation, the Grand Staircase. And then there's this regional sand in here called the Castle Gate. Very quartz rich, probably derived out of some of the sand dune deposits that were formed in the Jurassic. As those mountains started to come up really well at that point. And then above that, we have the Price River Formation and the Nielsen facies, which are the same age as Caparowitz, and the Dinosaur Park Formation, you know, Upper Judith River age things. And way at the top, we have in this area here the Ohio Creek Conglomerate. But as we go just out of sight, it's thickening into the Four Deep Basin upper lake beds of the North Horn. So we have late Cretaceous. Utah's Tyrannosaurus rex specimen came from over in there, where it was found with the sauropod Alamosaurus in the same beds, and Torosaurus utahensis. And we're really hoping there'll be more work in that area in the near future, because it's very understudied. Nice.
I've already got some questions coming in.
Sure.
Izzy wants to know, does Dr. Jim have a favorite dinosaur?
Gastonia.
I knew you were going to say that, yeah.
Everyone likes, wasn't it Utah Raptor? But no, Utah Raptor got me my job, so I do like Utah Raptor. I can't say it has done me well, didn't do me wrong. But I just love ankylosaurs, and Gastonia and its relatives, the Polacanthine ankylosaurs, are some of the spiniest animals.
They're pretty
Their
gnarly.
tails have these big triangular plates going down them that I liken to a chainsaw blade on a handle. You know, you don't want to get slapped in the face by this thing.
Yeah.
And it probably kept Utah Raptor from picking them off. It's one of the most common animals in these beds with the Utah Raptor.
Can you tell us a story about when you first encountered Gastonia? It was in that rock shop, right?
Yeah, I had been just discovered like a couple weeks earlier the first Morrison ankylosaur that I later named Mimor pelta. And I had a couple plates and some armor, and it was like, this is an ankylosaur, absolutely. But it was the end of the season, and I was heading to join a project down in southwestern Utah via the museum in northern Arizona in Flagstaff. So I was heading down the museum where I was going to stash my wife and baby granddaughter and some housing they were providing. And we stopped in Moab, and I went in, you know, we had lunch, and then, of course, I duck out early to go over to the rock shop, see next door, see what was up. And all of a sudden I see ankylosaur osteoderms sitting on this shelf, and I go up to the guy at the cash register and say, man, where is that ankylosaur stuff from? And it wasn't for sale. They just were displaying it. And he goes, well, did you look at the stuff at the bottom of the case? There's this big mass of rock at the bottom of the case. And also I realized there's this big section of armor going over it. And then, this bone down here, that's the ilium, the upper pelvic bone, very turtle-like in ankylosaurs. And it fused armor going over the hips. The only animal I knew of at the time that's like that was Polacanthus foxi from England. So I got real excited. And, you know, the osteoderms look like what we were seeing in the Morrison. He says, yeah, it's from the Upper Morrison, north of Arches. You know, I had to keep going to Arizona. So I called my bosses at the Dynamation International Society in Fruita and said, you got to hook up with this guy, go check out that spot, you know. So they went out there, and the guy was Rob Gaston, hence Gastonia. And Rob is one of the foremost molder and casters of fossils and mounting skeletons that I know. He does a brilliant job.
The Velociraptor skull that I have in my office, that's from Rob Gaston. Got that in 2014.
Yeah, and he sells this stuff, quarter the price of anybody else, which puts him in bad stead with the other people doing molding and casting, because Rob is so reasonable. But he takes me out here, and I realize this isn't Jurassic; it's early Cretaceous. And we started working in the site on the Gastonia material, this bench on the other side of what we are going to be naming officially Gastonia Ridge, and on that steep slope, it's way up this mesa. As we worked on that animal, we found a little theropod jaw, nice sharp pointed teeth, and finding other animals in a site is not unusual. There's mostly Gastonia, at least 6 animals in there, but there was a theropod and a few iguanodont parts. But seeing this jaw, it's a meat-eating dinosaur.
Yeah.
But all of a sudden I got a call after we'd worked there for a month or so. Hey, Jim, come over and look at this. And, and it's limestone. Really hard thing to kneel on.
Oh, yeah.
Oh, man. I don't want to go over there and look at your thing. What do you think you got?
Yeah.
I think it might be a cervical rib, which is a rib in the neck region. I'm not getting up to look at a cervical rib. Expose more, be careful, And he calls me, I don't know, Jim, you should take a look at it. It's like, okay, and get up and go over. I'm working on the thing with teeth. I'm in charge, so I get to work on things with teeth.
Nice. One of the perks.
One of the perks.
Yeah.
So I go over and look at this thing. I see this little groove in the side. And it was about the front third toward the point. They nipped off the very point of it. But the first part, I see this groove, and that's a claw. And I put my head down on the rock and realized it's only about this thick. As I uncover the rest of that, turned out to be the first holotype of Utahraptor.
Very cool. Yeah.
We now know that all the raptor bones in that site all go to one individual of Utahraptor.
Oh, really? Oh, wow.
So instead of just having the claws, the holotype, every bone in that site is part of the new hypodyne,
nice.
The holotype for Utahraptor.
Yeah.
So we have tail vertebra, we have lower leg bones, tibias, we have both premaxillas, we have dorsal vertebra, caudal vertebra, enough so a good ankle bone, so we can compare it against other animals. It makes it much more robust.
Yeah.
In terms of comparing it with other sites, and this has become real important with our discovery of at the Styx Quarry of a gigantic mass of skeletons of meat-eating dinosaurs. We're thinking of it hypothetically as a pack of Utahraptors that got trapped in quicksand going for an iguanodont. But other people have looked at the smaller animals and are starting to tell me those might be truodonts because they have big brains. But young animals, like our babies, have pretty good-sized brains for their body size.
Yeah. As
you grow, our brains don't keep getting that big, or it'd be a hard time holding our heads up.
Yep.
But so I'm a little off.
Yeah.
And I think in a few years, the next generation, some young paleontologists are going to work on this huge collection and figure out what's going on. My job is to escort the Utahraptor block into the future. So it's in good shape for science with good documentation.
I took a look at that one in 2018 when it was still at Thanksgiving Point.
Yeah.
I got to see it up close, got to touch the block. It's amazing. That is an incredible
dozens of skeletons in that block.
Amazing.
Yeah,
and it's interesting what you say too about the troodontid versus juvenile Utahraptor thing. We talk on my channel all the time about dinosaur ontogeny and about how so many of these dinosaurs change really dramatically as they grow and mature. And I wouldn't be shocked if the same thing happens with
I think we really, we have people coming in that want to name the juveniles, while they're still in the block. Where we extracted them.
I can understand the excitement. It's an amazing, incredible specimen.
Multiple disarticulated skulls. And I guess Jingmai O'Connor looked at the brain, because we had one that the whole top of the head came off so you could see the brain. And he said, that's one of the largest brain dinosaurs I've ever seen.
You showed me the photo yesterday. That's incredible. Yeah.
It's the biggest troodont for the body size, because it's an animal similar in size, troodont.
Yeah.
It's got a brain pretty much the same size.
That's impressive. Yeah.
And the thing we see with Utahraptor, what I'm going to talk about at Scientific Paleo meetings, is that we've got a number of tails, including the adult. We've got a big adult in the block, and the tail of the adult and the smaller tails do not show the extraordinary extension of the processes of the tail vertebra, that intertwine with each other to make it basically a stick. Velociraptor, Deinonychus, the Microraptorines all have this really stiffened tail. The dromaeosaurs, the first one ever named was Dromaeosaurus.
From Alberta, yeah.
We don't know its tail at all. We really have scrap for that poor specimen. We need more. Yeah. But the tails of these things that we have here that seem to be dromaeosaurs do not stiffen the tails as much as velociraptorines, and birds don't either. And troodonts don't do it like that. So I'm thinking that Utahraptor is actually closer to the stock that gave rise to modern birds, and velociraptorines are actually specialized.
Interesting.
Probably flightless. I think they're all secondarily flightless. But Utahraptor and the dromaeosaurines and other groups are further down the the evolutionary ladder.
That makes sense.
Velociraptorines.
Yeah. Well, cool. I've got another question here.
Sure.
Let's see. What's the biggest specimen you've ever found? It's got to be a sauropod, right?
Yeah. Let's see. Well, the biggest, probably partial Apatosaurus up in Combe Ridge, up in the Morrison.
Yeah.
I uncovered, found, right in what Bob Bacher used to refer to as the breakfast bench beds.
Yeah.
And up in those beds, I uncovered two huge Apatosaurus femur right next to each other. Nothing else, but they're bigger than me.
Wow. Did they just get washed there? Is it fluvial?
Probably Ajax.
Yeah.
It's pretty much this real dark, fairly organic mud.
Okay.
And there's stuff, a lot of croc teeth, come out of it. Lungfish, tooth plates. So Bob has always thought the breakfast bench was a real pondy, swampy environment. But those femora got there somehow. There's two of them, right next to each other.
Yeah.
The left and the right. And then nothing much else, around it. So why is it there? I don't know. Space aliens, who knows? Occam's razor does not have a simplest solution other than died somewhere nearby, and everything else
got carried away.
Everything else got carried away.
I mean, the femur's the biggest bone in the body, so it makes sense that would stick with it. Unless you count the sacrum as.
But we have no, explanation.
Yeah.
But that's the biggest thing, and and these rocks, the only sauropod I've ever named, Mirasaurus, was found just down behind me at the quarry.
Right where we've been digging. Yeah.
And at the time, it was the most complete Cretaceous individual sauropod ever found in North America.
Wow.
And my colleagues in Spain let me describe some Spanish dinosaurs, so I figured I'd turn the favor around and let them take the lead on this. They figured out this thing was a Torreosaur. And Torreosaurs are a Jurassic group in Britain. Torreosaurus is the largest dinosaur known in Europe. It's a huge, huge animal. These guys, both Mirasaurus and Moabosaurus, which are both Torreosaurs, by their reckon. There's Americans that just, they're related to Mirasaurs. I'm not going to get in that fight, but all the Europeans, totally convinced of it, all of them, that work on sauropods. There's kind of a North American-European conflict on this. I think I agree with the Europeans, because if they're right, and even Cedarsaurus, which is a brachiosaur that occurs in the yellow cat, is related closer to European brachiosaurs than to Brachiosaurus. That says all the Morrison sauropods went extinct at the end of the Jurassic.
Wow.
That's a big deal. But it'll take further research. There are things to do. We do not know it all.
Shoot, the end Jurassic extinction.
And in North America, we still have no evidence of stegosaurs at this level.
Yeah.
Though they occur in the early Cretaceous in Africa, Europe, Asia, and I'm not sure about Argentina, but pretty much every continent's got basal Cretaceous stegosaurs. They'd probably go extinct with the Aptian extinction that we discovered here. This mid-early Cretaceous mass extinction of the classic Wealden type stuff, like
with baryonyx and those critters. We
don't get baryonyx here.
Yeah, exactly.
And the Spinosaurs make it to the Cenomanian extinction. But the end of the Aptian, all the Polacanthines go out in Europe and North America. Probably the Psittacosaurs go extinct in Asia. And then all of a sudden we start getting nodosaurs both in Europe, North America. In North America, we lose all the thumb-spiked iguanodonts, the styracosternids, and are replaced in the cloverleaf-style faunas by Tyrannosaurs, which are just giant animals. They still have 5 fingers, real primitive, just filling the role of bipedal plant eaters, and are really just endemic to North America following that extinction. And that's a period of massive volcanic eruptions in the southeast Pacific, Yogo-Java Plateau region under the ocean, which people claim is the biggest series of basalt flows in Earth history.
Holy cow, that's nuts.
Bigger than the Kant traps.
Bigger than the Siberian traps,
they used to define other extinctions. So it's pretty interesting. There is definitely more work to be done on this stuff. The Jurassic-Cretaceous boundary and the Aptian, 2 extinction boundaries. And at the top of the Cedar Mountain, top of the Mustn't Touch It, records a 3rd extinction with the origin of Alaska, with the collision of Rangralia into western Canada, creating the ancestral Brooks Range, which ran right over the North Pole, which was off Alaska, what is Alaska now. So it was snow-capped. I don't think the North Slope dinosaurs have anything to do with Asia. They had to come down the Pacific coast and come in here at that time. But the Mustn't Touch It member at the top of the Cedar Mountain has the first Asian animals coming in. Our really common animal there is Eolambia. And its closest relative is Probacterosaurus in Asia in the late Albian. And these are basal Cenomanian years, right there, a couple million years apart. And if someone told me, Jim, you're wrong, it's actually another species of Probacterosaurus, it wouldn't surprise me that much. They're very close.
Just coming over from Asia.
And there's no ancestral animals like that. Eolambia is a bit of a thumb spike. It's not like the older iguanodonts, but they still have a bony spur at the thumb point on their hands. Those hadrosauriforms, in the earlier part of the late Cretaceous.
Well, that idea that there's still so much work left to be done out there kind of brings me to the next question, and that's, is there still room for amateurs, for lay people, to contribute to dinosaur paleontology?
Oh, absolutely. You and I are talking about a couple projects, things that are already out there, and, you can pretty much do some armchair work. You got to be careful. You really should collaborate with people with a little, because we do have armchair paleontologists that come up with some wild things. Russian just renamed all the North American stegosaurs. So every other skeleton's a different genus. No one believes it. The guy never saw a stegosaur in his whole life, but he published papers in Russia. We still got to deal with it. But there is so much science to be done. We were talking about some projects with ankylosaurs, but there's many, many others. And there's so much more to discover.
Definitely.
If we had enough funding, I think I could find another 100 dinosaurs.
Just here in Utah?
Yeah,
wow.
Easy. Right now, when I named Utah Raptor in '93, there were 22 dinosaurs in Utah that could be taken to genus. 22 total. Now there's like 130 with at least 20 more in works being named. So we've gone up over 100 new dinosaurs in Utah in the last 25, 30 years.
Holy cow.
Actually about 30.
How many are from right here in Dolling's Bowl?
Here we got 4 so far.
So
we know the big Carcharodontosaur, these big teeth, is new, but
need to find some skeleton material.
Bones, not just teeth.
Maybe next week we'll find it.
I tell you, just all of a sudden we start finding large theropods. Mirosaurus was a mired sauropod. It got stuck in the mud. So the bones were laid out, scattered, but the legs were just plunging down several feet below. And as we worked those, we went underneath and we discovered the bed we're working on now. This beautifully preserved iguanodontian bone lag, beautiful preservation. Certainly, if we have a mounted skeleton of that iguanodonts coming out of that lair.
Nice.
But we would never have found it if we hadn't had to dig and go under the feet of this sauropod. We would not have known there was this beautiful horizon underneath. We would have stopped, and that lair would have been waiting another 100 years or so before the bones naturally started getting exposed from it.
Is that from right next to where we've been digging?
Right there,
at
yeah.
Lakeport?
I mean, that pit where the wash,
Yeah.
garage, that's the Mirasaurus type locality.
It's so close. That's nuts.
And Don's site is where Yorgovuchia was found. One of the initial discovery fossils.
Yeah.
And Yorgovuchia is a big dromaeosaur.
Possible ancestor of Utah raptor.
Possibly the ancestor of Utah. It's certainly related. It's a dromaeosaurine. It's not quite as big.
Yeah.
But it's big. It's bigger than Deinonychus. It's certainly in the top, 6 or 7 size dromaeosaurs. But that was found there as one of the first things we got out of this site. And then, of course, the big iguanodon here shares a feature with a thing we named Iguana colossus from the lower Yellow Cat near Green River, Utah, about 30 miles to the west. And because, we just don't have very good age control between these sites.
Yeah.
We're trying to be careful. It's certainly sharing features with Iguana colossus, but it could be another related taxa.
So that's the critter that I've been digging out of the quarry for the past week, along with,
and there's so much material it's going to be one of the best known iguanodonts in North America.
That's awesome.
Because we have a ton of fossils, at least 20 individuals so far. And I think if we just kept going in another 50 years, we get more than 100. And growing. We have femora this big and femora this big.
It's really impressive.
So a complete growth series of them. There's a lot of skull material. We have like a dozen jaws. So there's, going to be, the next generation. Someone's going to work that stuff up and really compare it to the type material of Iguana colossus and tell us if it's the same thing or not. And basically, there's no rush.
Yeah.
Let's do it right. We've got the fossils here. And then we got a new ankylosaur, which makes me happy. It's a new taxa. And it seems like since it's right at the bottom, rocks that are like 140 million, it does seem to share characters with our Jurassic ankylosaurs and with Gastonia, which is the top of the Yellow Cat. So it really does seem to have some intermediate characters, but it's clearly distinctive. We can tell it apart just on the armor.
Nice. Here, people are saying there's a smudge on the camera. I think it might be a scratch. But let me check real quick. Yeah. I've got another camera back in camp, so it's not the end of the world if this lens is scratched up. But let me just turn the camera a bit. People are saying the smudge is over your face, which is not ideal.
Not ideal. I don't know. It depends on how you approach this. Some people go, "Oh, dang it!"
Witness protection program.
But you can see the quarry out behind me. You might see a white dot with a wide angle. It's not very big, but that's where these guys are digging and bailing water.
Yeah. Oh man, the rain yesterday was. It just came out of nowhere. This little cloud didn't look like it had anything.
Oh yeah.
It really packed a punch.
Yeah, we were. It starts raining, and we're just like, oh, it's going to just sprinkle for a while, and go over, and all of a sudden,
worse and worse.
It's like, okay, Noah's flood has started. It's flowing. We were very surprised.
Yeah, definitely. So we got out there this morning and bailed some water out of the Iguanodontian quarry, and that was, I don't know. We'd done some decent trenching and everything, so the bone's going to be okay. But
if I had moved the wash, believe me, that would have been full.
Oh yeah, yeah, for sure. Yeah.
Now, did that wash flow at all?
Oh yeah,
that did.
Definitely.
Oh yeah, okay.
Yeah, it was. I took some video of it. It was pretty impressive. That berm that I built there, really glad I did, or that would have been coming into the quarry. Holy cow! Yeah.
It's really important to quarry engineering. People don't think of it.
I did a lot of that in the Hell Creek, the Leptoceratops site. That was
there was a quarry the Brigham Young University did for Apatosaur near the Mill Canyon dinosaur site, right in the side of a wash. And basically, when I decided to check it out, and I went there, the thing was filled with water. There were pelvae, probably over a 10-foot deep quarry hole. It filled with water. You could look through the murky water and see white of these big jackets over the pelvis and things. It came out okay. The bones are prepped and they look good, but generally I don't like to see my jackets underwater.
No, not a good thing.
Particularly in the Morrison Formation, because often those shales, they didn't go into the bone at all. They swell. Swelling clays that are derived from volcanic ash.
Yeah.
And as they expand, they blow your bones up. Yeah, I saw a whole beautiful Camptosaur bone turned into dust one time.
That's a nightmare.
Cover your quarry, particularly in the Morrison.
Yep. So we've got a question about why Utah is so rich in terms of dinosaur fossils, and
it's really fortuitous, let me tell you. Part of it is, during the late Paleozoic, you have the ancestral Rockies coming up. Right along the state line here, there's a mountain range, the ancestral, Uncompahgre Mountains, comes up, and there's the fault on it. There's miles of fault displacement. So back in the late Paleozoic, going all the way, it wasn't until the end of the Triassic that it finally got buried. Those sediments were shedding to the west, and then we have the Pacific Ocean. Coming lapping right up into western Utah. So sediments are shedding this way. About where we're sitting, we have things like Chinle forming, Upper Triassic and the Moenkopi, which even in this area has little marine tongues, that are coming in from the west. And there are terrestrial animals in those rocks for the Triassic. Then you start getting a mountain building episode further south and causes a Foreland Basin. So the Chinle, this upper Triassic, thickens to the southwest. It doesn't do it so much to the northwest, but it really thickens that way. The lower Jurassic does the same thing, and we have that fossil record there. So the seesaw, this is up, shedding this way, and there's a little bit of shedding that way, but it's just filling that basin.
Sure.
Then we get quiescence slowly through the Jurassic, fills in this basin, and the Morrison really, that's why the Morrison thickness is pretty uniform all the way up to Montana, to its pinch house, just kind of last fill as the late Jurassic seas retreated in Canada. And because of salt, in the early Cretaceous, this place started subsiding, where sediments just eroding over the Morrison. Everywhere else, all the way to Montana, you have this huge gap. And here, because of salt being squeezed to the south like toothpaste out of a tube, we get a little basin form from the weight of those sediments pushing down. And we get the yellow cap member of the Cedar Mountain. And we have the two oldest Cretaceous faunas in North America. I always love to say, we don't have just the oldest, we got the two oldest Cretaceous dinosaur faunas in North America. And then the rocks we're sitting on have the last remnants of these Wealden-style dinosaur faunas, different species. But, we think this might tie the Lakota up in the Black Hills region, which is the beginning of deposition there. These rocks here go right over and join to the top of that big river conglomerate that was, boulder conglomerate, not great for bones, that occurs over in the western San Rafael swell. So this would normally be the base. Except we have all this older material here, giving us a record we didn't know before. And, if you got 25 million years between your first Cretaceous record and the last Jurassic, you can't talk about extinction. Anything can happen in 25 million years.
Seriously, yeah.
It'd be just total gradual change. But now that we've really been closing that gap,
it's clear that there's
something seriously happening. With a faunal turnover at that point.
Which is, it's almost complete, right? I guess you get ankylosaurs that make it across.
Basically, we have almost the base of the Cretaceous here. Most of the gap that's left is in the top of the Morrison. But we have latest Jurassic Morrison-style faunas in Portugal that go right to the boundary. So we know the, things, Supersaurus, Stegosaurus, all that stuff just kept going there to the end of the Jurassic. So I think pretty clearly to me is something is happening at the end of the Jurassic, and it's just not explained by a big gap.
So that's really interesting. Is that reflected in marine stuff like ammonites today?
I'm not the ammonites. I'm not sure how good they are, but there is these little capsule-shaped microfossils or calliopernids or something, calliopellads, that are biostratigraphy, real useful in late Jurassic, and they go right to the base of the Cretaceous, into the base, and then go out. In fact, a lot of the Europeans think we should raise the Jurassic Cretaceous boundary up into the Berriasian, and to me that might make some sense, but we got to date the bottom of this, because we definitely have a Cretaceous fauna, and this stuff in here is probably at least upper Berriasian.
Okay.
Because the upper yellow cat we've got very well dated is what we call Valentinian, about 135 million. And this stuff is lower.
Sure.
But we don't have as many good dates in this. We have better dates at the Utahraptor level, which is real exciting. And the paleobotanists we work with, looking at the pollen, this whole yellow cat interval is before flowering plants. So we have this Cretaceous assemblage of animals. There is no flowering plants.
Wow.
The oldest flowering plants we have are in Liaoning, China. Fruta fossa and things, and they're up in the upper Borromean, maybe the level we're sitting at here. And the next level up, at the top of the Ruby Ranch, are Lake Carpenter, Facies. Those things have the first flowering plant pollen, and there's only monocots. Two
No
major
dicots
groups.
yet.
Yeah, no dicots, just monocots. And that's the way it is in the antler. There's a basal unit to get those ironstone, tracks before you get to the, good fossils. And that stuff has just monocots. What's neat about here, the paleontologists from the Smithsonian's excited. We have a volcanic ash this thick that we got a great date on.
Nice.
This is happening at about 115.5 billion. I could go on further, but 200,000 years plus or minus. So it's the best dated origin of angiosperms anywhere. So that's pretty exciting, but they're monocots. And I'm waiting for our paleontologists. Carol Houghton at Smithsonian is really working on this. This is like, I think, the cherry on her career.
Nice.
She's kind of semi-retired emeritus there.
Well, very cool. Can you maybe talk a little bit about radiometric dating and how it's useful for us in a place like this? Like, how do you use that in the course of your research?
Well, the early dating work here, volcanic ashes are best.
Yeah.
Because you can date them directly, and they're
zircons.
preserving a good signal. So, the Lake Carpenter, we got a nice ash in it that we can date, because the radioactive elements are coming in. But in these rocks, one of the techniques that's been applied is looking at the zircons that are reworked into the sands. And zircons, you can do uranium lead dating on them, and they're nearly indestructible. If you take a piece of this quartzite and date it, you'll end up with zircons that go way to deep Precambrian, probably sourced, from the East Coast, because the rivers kind of came along north of the Ouachita Mountains and swung up here back out to the sea. But you'd also get zircons that dated Jurassic for sure, because one of the things we've discovered with these rocks is more and more Jurassic zircons as we go to the east. But we'd also get some early Cretaceous. And those early detrital zircons, what gives you is the maximum age. Because, to get a zircon with a certain date, it already had to exist.
Right.
So if you're getting dates of like 130, I mean, it's not saying it could be younger, but there was a 130 ash that's giving you zircons.
Sure.
That gets deposited. So it can't be, any older than that, because that's your maximum date on this stuff. But the group I'm working with from the University of Kansas has started, instead of looking just at the sands, and a rock that big will have 1,000 zircons in it. So you break it down, you're going to be able to do a whole history of that rock, provenience study. It's really important tool. But they're looking at the fossil soil horizons, because some of our fossil soil horizons in these rocks could have taken tens of thousands of years to form. And if a volcanic ash comes down on that surface, they're rooting and burrowing insects mix it in, so we could catch zircons that were coming down on that surface. And they're getting better age data. So up at Utahraptor Ridge, where we have the thickest yellow cat sequence, they have dates at the very bottom, right on the unconformity of 142. Pretty good date. And up at the level where we have the Utahraptor mass mortality, they've got ages of about 135. The calcrete, the interstitial stuff, is like 136. And those are pretty good, and they're in the right order. You always get, I've seen papers where all of a sudden the dates here up at the high are older than the ones below. I get really nervous when I start seeing that. There's some problem somewhere, guys. But the new stuff the University of Kansas group are doing with us is really good. And we published a paper fairly recently on the, really making these older, because everybody, well, this is like basal Aptian, because the original detrital zircon ages weren't that good. But they're getting better, and the best dates are coming out of these paleosols.
Nice. I know people at home are going to want to know if you have any advice for anybody who might be a young aspiring paleontologist, or maybe they're not so young anymore, but they'd like to become involved with field work and that kind of thing.
Yeah, being independently wealthy, great start. Great start if you want to be involved.
I wish I had that. Yeah.
Yeah.
But like volunteer
if you're
programs.
Going, there's lots of good volunteer programs in Utah. We have Utah Friends of Paleontology. In our digs here, the reason we're working here when it's so hot is because of the academic calendar. Because we really appreciate having students, graduate students, and even highly motivated undergraduate students, because they actually will listen to you and take directions. And do good things. We had bad luck with the Explorers Club in New York.
Oh no!
Because they won't answer to anybody. They know more than we do. So these captains of industry doing their safaris in Africa, things. We don't need them.
Yeah.
But we try to bring students out as much as possible. But as a student, if you're going into college, you want to become a paleontologist. There's lots of ways to skin a cat. People make a living writing books about paleo. People, you're making a living
live streaming,
doing paleo art. People, illustrating books and things. Being a curator, paleontologist. Those jobs generally need a master's degree. And to be a senior curator and teach in a college, you need a PhD.
Yeah.
So starting the university thing, I always advise people, if you can major geology, and minor in biology, or do a double major, you're going to be much better off. And graduate programs, there you pick the individual you want to work with. It's not the school, I want to go to Harvard because it's a prestigious school. But there's no one working on dinosaurs at Harvard.
Yeah, exactly.
If you're interested in dinosaur paleo, you go to Harvard, you're going to be working on tetrapod origins, because they had paleontologists there. I was working at the origin of amphibians and things. Good work, important study, but you're not going to get to work on dinosaurs. So you want to pick the individual. It's very good to go to Society of Earth Paleo meetings as an aspiring student.
SVP,
Yeah, because they have the graduate student forum. That's where you can go and say, well, what's this guy like to work under? Because some people are horrible as graduate advisors. It did many levels. I won't go into it. But other grad students can tell you, this is a great person to work under. This person will never read your thesis. They'll make you sit for an extra year before they get to it. And people are like that. We're all different people in this profession. But the grad student is shopping for the individual in a good program. If they're they got to have a graduate program at their school. They're really good people. I work with a guy by the name of Ed Simpson a lot. He was the guy that really helped me prove that it was a quicksand mass mortality at Utah Raptor Ridge that trapped all these things. You know, I came up with the theory, but Ed knows quicksand.
Yeah.
And he's at a 4-year school. And a lot of his students go on to grad school, but he's a brilliant geologist. He's a GSA, Geological Society of American Fellow, which is very prestigious. You know, they realize you are a top person to get that prestige, but he's only at a 4-year school. So as much as I think Ed would be brilliant to do graduate work
students,
under, he only has undergraduate. So you need to shop around. And the master's level is good. The bureaucrat jobs, I didn't mention those. Bureau of Land Management, National Park Service, Forest Service. There are jobs, and there's more of them because of new rules.
Utah Geological Survey.
I have paleontologists. North Dakota Geologic Survey is for paleontologists. So there are this level, you know, in the paleocrats that issue the permits and things. And I get to do a lot of research, but I'm also having to issue permits and deal with, you know, fossil theft, having to testify in terms of certain cases on occasion.
Well, I mean, talk a little bit about like what you do day to day as part of the Utah Geological Survey as the Utah State Paleontologist.
Well, and, you know, I've been in, you know, this is my 23rd year as state paleontologist.
Wow.
So the first thing I tend to do is open my email and go, Oh man, and work on that for a few hours. Put out fires, things, communicate, try to see, what things I can fulfill for people's requests.
Yeah.
Every once in a while look at some pictures of rocks that people send and say, that's a skull. No, it isn't.
Yeah.
Once in a while people send me a picture, and that's really important. Where'd you find that? But I do that the first few hours. But looking at permits, interacting with all the different federal agencies, other scientists working in the state. I try to be a helping hand. I want to see people work in Utah because it's an amazing place. The seesaw. We only start at the beginning. Mountains come up here, shed sediment. Dinosaurs, the first part of the Mesozoic. Severe mountains come up in the west, give us sediment, Cretaceous. The other side, the seesaw of mountain building, either side, is why we have the entire Mesozoic represented by dinosaur faunas, terrestrial faunas, which no one else has.
Yeah, seriously.
Record.
I used to think we had it in Montana, like, Montana, best state in the country for dinosaurs. No, Utah has it beat by a country mile.
It's just this place is hot.
Yeah,
it's, if you're going to work in the summer, Montana's a little more benign than down here.
Sometimes, I don't know.
Lately it's gotten pretty dang hot up there.
Yeah.
But, the early explorers, the trains went through Wyoming, and up there the wagon trains went through.
Yep.
Those are much more, because here, you go on the other side of that, you have the San Rafael Reef. And the highway only cut through the reef in 77. You think, here's the highway to Los Angeles. You had to go all the way down and around almost to Arizona, before you could get past some of those features.
Inhospitable country,
and they call these giant uplifts reefs because they're, obstruction to navigation.
You said you could see it from space, right?
Oh yeah, the swell, easy. It's a gigantic doubly plunging anticline.
Yeah, so we went there last week. Jim led a big field trip for us, and we drove all around to see all these different early Cretaceous sites, and that was amazing.
Now, the San Rafael Swell was proposed to be a national monument a few years ago, and George Bush said, well, it should go for a vote, because, Grand Staircase in Utah was just, declared, and a lot of people in Utah were a little ticked off about it. Some of you may know, still people, talk about this stuff, but they put it up for a vote, and it lost by 76 votes. Which is so sad because
that's so close.
It would have made Emery County so much richer. Yeah. Because it's, we have like the Little Grand Canyon in there, Temple Mountain. It's just one of the most beautiful places in the world. Yeah. Barely, the public don't even know it's there. And the whole swell is about as big as the whole Grand Canyon region.
Wow.
It's a big area. It's not like there's gold and silver and economic materials there. Right. Once upon a time, maybe in the Cretaceous, it was a major oil reservoir, but it had been exposed and all the oil went into the atmosphere, evaporated. So it's a great place to study, a giant oil reservoir that's been laid bare. It's
that's pretty cool.
Dry of all its
oil. And it bleached all those rocks like you were
talking
about.
They're all white, because of the organics.
Really strange.
Reducing the iron.
Chinle Formation, Triassic rocks that are
white.
Nuts. Those things are usually red.
It was all saturated with oil years, millions of years ago. But it's such a beautiful place. It's just, and the people in Emery County would have so much more money. If they had
made
it
were a national monument or a national park.
Partly because a certain group at the meetings, we had these big hearings, wouldn't commit to the boundaries that were proposed by the governor. And if they had done that, it probably would have passed. Do
you think that'll ever go up for a vote again? Will that ever?
I don't. I wish it would, and I know a lot of people that live in Green River and would love to see it. Yeah, because it'd be more money. They'd have better schools. This is a very rural
hotels
area.
And tourists coming through.
As you show around here, we can see 100 and something mile area around here, all the way to Colorado, and you can't see any sign of humans but us. In this vista. It's a gigantic area. It's not like there's ranches out there. There's no one living out there.
When I was working up in the Hell Creek in Montana, we'd be out in the middle of nowhere, but there's always signs of human habitation. There's always fences. There's always cattle.
Well, so much of that's private land.
Exactly.
Here, people didn't homestead. This is like, back in the 20s, the grass on these plains out here was as high as a horse's belly. So there was a lot more cattle grazing out there. But during the Big Depression, during the Dust Bowl era, we had a continent-wide drought, and the level of grazing stayed the same.
Yeah.
So basically all the grasses turned from a desert grassland, high desert grassland, to a high desert scrubland. So it's not nearly as productive as it was. And then cheatgrass invaded, invasive grass. And cheatgrass lives for a couple weeks and turns to steel wool. But basically it poisons other grasses, so they have a hard time establishing. But you see around me, here's the scrubs, blackbrush and things, and even they, with climate change, I see ephedra there. Basically a nice Jurassic plant.
Is it really?
Oh, yeah.
That's gymnosperm?
Yep. It's not a gymnosperm, it's Netales.
Oh, okay.
Netalian. There's only 3 genera alive of that plant group today. But
and it's right
pretty
here.
Big group in the Mesozoic.
With sincere appreciation and gratitude, thank you very much for the 100.
Interesting.
We have quite a number
What
of
kind of
species of
dinosaurs
ephedra
live there?
out here. I got a nice one in my rock garden. But basically, that's a native plant. And some of this brush is native. For your viewers, you see, you can't see in this view, but behind us over here, see all these yellow dead things.
Yeah.
Those are tumbleweeds, Russian thistle.
Yeah, invasive.
Yeah, they're invasive. You think Russian, the symbol of the West.
Yep.
And all those
tumbleweeds there.
Tumbleweeds. And Russian thistle came into North America, first recorded in 1857. Within 10 years, up in, I think, North Dakota. And within 10 years, it was everywhere.
Jeez.
Because it's so good at seed dispersal. But it's a, introduced plant. Utah juniper, is all these little plants around us. The pygmy forest. Those are native, but so many exotic plants here. The river bottoms are taken over by Russian olive. And, it's just, we need to manage these lands. You can't get rid of this, tamarisk, Russian olive, all these invasives that have taken over the riparian habitats and have really affected our native birds.
Seriously.
Beaver eat willow. They don't eat tamarisk.
Right,
and they're
so
replacing
it just takes over,
It's really
we had the same thing up in Montana, too.
Seeds in the saddle, in the saddle blankets and things that came in. Tamarisk they planted on purpose for windbreaks.
Gotcha,
off.
Yeah. Is cottonwood native like that, too, or is that also
Cottonwood's
introduced?
native.
Okay. I know that's everywhere up in the Hell Creek.
They had
it's like the one plant that does well.
Good seeding episode in the last 30 years. Along the Colorado and Fremont River, some of these things. If you look, you realize there's no young cottonwoods on these rivers. They're all big trees.
I mean, the cows eat them when they're seedlings, right?
Yeah.
Yeah.
And they're just
in Montana.
And they haven't been having a good, set.
Yeah.
Because it takes a certain level of flooding to transport those seeds at the right level where there's going to be moisture so they could grow, but not underwater and not up in the desert part, of where it's flooding. So it's a real, it's got to be timed correctly. And about 5 or 6 years ago, we had a decent set of cottonwoods in Utah. So it was 30 years. There's no cottonwood in this state that was under 30 years old. And
that's nuts.
It's climate change. What's it going to do? Hate to lose the cottonwoods.
Yeah, seriously.
But this is what we got to live with.
Yep.
But folks, look out here. This is the entire Cretaceous.
This is pretty incredible.
Over 2 miles. You can't see anything but Cretaceous from where we're sitting, and we're looking over huge distances here. It's all it's the last half the Mesozoic.
I've got a viewer who wants to know, speaking of this beautiful Cretaceous terrain, what's the most scenic or beautiful place that you've ever done an excavation?
Man,
that's got to be
a lot of
tough
places.
One,
yeah, I mean, Utah Raptor Ridge. I've got a painting that was done of us working up there. That George Callison. That certainly is going to be historic because you can see my suspenders. Me
nice.
Working the site. With the Utah Raptor block, and you can see all the way to the La Salle Mountains from an incredible view. But man, I mean, Portugal, the Laurentine Formation on the sea cliffs there.
That's got to be beautiful. The ocean right there.
Badlands going right to the sea.
Oh, man.
It is gorgeous.
At the end of the day, when you're done working, you just go down and take a dip in the ocean.
I mean, down in Baja, the Escondida Formation, Upper Cretaceous, right down to the sea.
Nice.
So you camp on the beach and then go prospecting the Badlands. Those aren't bad, but we have many places that are gorgeous. Gaston Quarry on the other side of the Yellow Cat Road. You can look out and see arches, see Skyline Arch in those areas. Look down, there's the La Salles, which would be snow-capped until early July.
Jeez.
This area is so beautiful in the spring because of the snow caps still staying on the high elevations.
Yeah.
You get to this kind of, it kind of bakes out a little bit.
Yeah.
No green, all the cheatgrass. That all that brown in front of you, that's mostly cheatgrass.
There's a little bird over there. What is that? It doesn't look like a rock wren.
No, what is that?
It's got flappier wings like a hummingbird. It's kind of greenish.
Yeah, longish tail. Is a little flycatcher of some sort.
It looks like a flycatcher, yeah. That's bird number 12, I think, that I've seen. I've been counting the birds, not bird species, individual birds.
This place used to be, we still get antelope wandering into the quarry. You working, real quiet, and all of a sudden you look up, there's an antelope standing there.
Very cool.
North American pronghorn, not a true antelope.
Antila caprids,
a native, one of the few big native animals. That's been here since the Eocene. They first started evolve.
The last member of its lineage. Last Antila caprid.
One in the world. Yeah.
And such cool critters.
And the fastest North American animal, and everyone they
evolved to outrun the American cheetah, right?
The American cheetah, which is actually a specialized jaguar. But that reason they can run 65 miles an hour, pretty sustained, is because of the North American cheetah. They went extinct at the end of the Ice Age, but we still end up with these antelope, the pronghorn, that can outrun anything easily. I mean, the only thing that gets preyed on out here that's pronghorn or young. Actually, they've eagles will take them out once in a while.
They'll take up pronghorn?
Oh yeah.
The juveniles or adults?
Adults even.
Holy cow!
Yeah, eagles out here will take out deer.
Golden eagles.
I've had someone witness golden eagles taking out a deer.
I've heard accounts of that.
They just heard the screaming and they're like, "What the heck's going on?" It was in this kind of PJ stuff, a little thicker than this, way low on the PJ habitat. And they come around, and all of a sudden, here's this deer just bleeding, and this golden eagle's just bombing it, just raking it with its talons.
Shoot!
And this poor deer is just screaming, because it's there's nothing it can do.
It can't escape; it's coming out of the sky.
Yeah, and I use a picture in talks when I say, birds aren't dangerous, showing an eagle taking out a pronghorn adult, and
that's nuts.
It's nasty. I mean, because they don't do it fast. It is. For those big animals, when they decide they're going to take one out, it takes a while.
Shoot, and if a 10-pound eagle can do that, imagine what a Utah raptor could do.
Oh yeah. I mean, it's
insane. Same basic kind of body shape too. I mean, bipedal, got the big claws.
But you look at dromaeosaurs, their radiation. We're talking, what is it, Halzacosaurus?
Yeah, Halscaraptor.
Which is basically a goose raptor.
Do you think dinosaurs are put together
and then the Ulanlegids.
Yeah, Ulanlegids,
the southern hemisphere.
Yeah,
those are probably fish eaters.
Elongate rostrum.
I mean, we're just seeing that the diversity of dromaeosaurs is so high compared to what we thought, in the past.
That's so cool.
When I named Utah raptor, it was the sixth one ever named.
The sixth dromaeosaur ever?
Sixth dromaeosaur ever.
Shoot.
And now there's over 40, that are dromaeosaurids.
Yeah. Did you, is that part of the start of the trend to name them raptor as the suffix? Was Utahraptor the second one with that suffix?
I'm not sure.
It was Velociraptor and then...
Yeah.
Utahraptor might be the second one.
Yeah, because, we were thinking, the Crichton book, and the whole bit.
Yeah.
And, and Bakker didn't name it, but he did say, you might want to name it for Utah. Because there was some political stuff. I was in Colorado, and my former state paleontologist and head of me didn't want anyone working for a group like Dynamation that I worked with the museum, working in Utah. So, it's like, maybe if you name it after Utah, they'll take it better. And I have to admit, it's probably why I'm now the state paleontologist of Utah. So it wasn't a bad move.
It's a wise decision. Yeah. And is it now officially the Utah state dinosaur? Too?
It's officially the state dinosaur. Yeah.
Nice.
Yeah,
Allosaurus is the state fossil. Utahraptor is the state dinosaur, which is cool.
Yeah, and I think in Oklahoma, Saurophaganax is the state fossil, and Acrocanthosaurus is the state dinosaur.
Nice.
So they have two. A number of states have both a dinosaur for a state fossil and a state dinosaur.
Yeah.
Not everybody's got a state dinosaur, obviously.
Yeah.
Ohio doesn't have a state dinosaur. Sorry, Ohio. Or
Nor does
Indiana,
Alaska.
Illinois.
Hawaii.
Alaska could have one.
They could.
Yeah, they just haven't picked one yet.
Actually, Hawaii might have a state dinosaur. It might be the Hawaiian honey creeper.
Yeah. Well, we got 3 because we have the seagull too.
There you go. Yeah. The California gull is the state bird.
California gull is our state bird.
Funny story.
Yeah. So we have 3 theropods. As state fossil, state dinosaur, and state bird.
That's great. Yeah.
Yeah, we like theropods in Utah.
Yeah. But ankylosaurs are your favorite. What do you like in particular about ankylosaurs?
Well, I love trying to figure out what they look like. Because the ornament, unlike stegosaurs, the ornament's sticking to the skull for the most part. But ankylosaurs, it's attached to the skin, so it falls apart.
Yeah.
You get ornament on the head that stays with it, and they really fuse up the head, so we get a lot of good ankylosaur skulls. And then they develop these rings of armor that fuse together on the neck, which are and these are real important, for species identification and genus identification.
Diagnostic,
Because, you look at like the late Cretaceous ankylosaurs from the Judithian, there's like 6 taxa that all used to be Euplocephalus dutus, and now they've subdivided it into about 5 or 6 genera.
Have they really?
Oh, yeah.
I haven't been keeping up on
you got Anodontosaurus, Oshikotovi, of course Euplocephalus, Dioplosaurus. I'm trying to think of the. I don't work in the crown up that late in the section.
The tail clubbed ankylosaurs.
They go from 1 to there's like 5 or 6 now. And there's some debate. Scolosaurus is distinct taxa now. And they're all lumped together. So the old reconstructions of Euplocephalus are actually combinations of Scolosaurus and other animals. It's a total hodgepodge. The Batat Euplocephalus, which when it was done was well done.
The toy one?
But it's totally based on a composite of multiple animals.
Interesting.
The wide tail clubs, the ones that kind of go like that.
Yeah.
That's Anodontosaurus.
Oh.
Where Euplocephalus proper and Diplosaurus have fairly round tail clubs.
Yeah.
But then there'll be things, cervical rings are really different. And we see that with these polycanthines, that the skulls are really similar to each other. In Polycanthus in England, they just discovered a skull there that's hopefully will be submitted for publication this fall.
Nice.
But it looks just like Gastonia. But we look at Gastonia, there's other features that are different. The pelvae are real different. Things like that. It's clearly not the same genus. But the big thing that's clearly different is the armor. The big tail plates and shoulder spines and things.
Sure.
The animal superficially has a very different look. And evolution acts on the outside of the body a lot.
Yeah.
So, ceratopsians, a lot of what you're seeing is related to sexual selection.
Yeah, display.
And I think the same with ankylosaurs. These guys are developing armor, and particularly with the polycanthines, these, for a plant-eating animal, these guys really look forward.
Yeah.
And the way the head domes and the front of the brain case, there's like this gliding joint to the front of the skull and the skull roof. The pterygoid processes are not fused on. There's just this little socket. You can see these things fighting by just, they're not running at each other.
Yeah.
Standing there, looking at each other, and then whoomph, and hitting their heads together. And,
sure, kind of a shoving
some of them, notosaurs start locking their side horns, on the shoulders. But clearly these things, ankylosaurids and notosaurs don't see as far forward as polycanthines, but those guys look forward more than almost any other plant-eating
Good
dinosaur.
Depth perception.
Yeah. And it's mainly, it's not for catching prey, making sure that plant doesn't escape. It's for how they interact with each other. And when you look at the biomechanics of all the thyreophorans, they all have these really specialized forelimb shoulder girdle areas, and they have these quite long legs in the back
for kind of pivoting.
These things it's all pivoting, keeping the tail
makes a lot of sense,
pointing at theropods. But stegosaurs, polycanthines, struthiosaurines, nodosaurs, ankylosaurs, they all do it in a distinct way, and within the groups, those girdles are really stable.
Yeah,
but they're different than the other groups. It's really interesting. It's like what's doing this? They found another solution to the problem of how to keep your butt pointed at the bad guys. So, whether you're slashing with blades, slashing with a club,
or with spikes,
or stegosaurus from that thing is great. That Mayan battle axe tail of it. There's one in China with a battle axe. Looks like these two big plates at the end of the tail. And that stuff eventually, it's probably an ancestral ankylosaur.
Yeah, it turns into the club eventually. Yeah.
Yeah, and Victoria predicted that. And they've got one like that in Asia. I've seen it personally. I'm not writing it up. It's someone else's project. I wish they hurry up and publish. But it's a neat animal. It just totally fulfills what Victoria Arbor predicted.
That's really cool. Yeah. Another ankylosaur worker, Victoria Arbor. Yeah. Yeah.
And that's what happened when we discovered Zuniceratops. We get this animal that's really more protoceratopsian grade.
Yeah.
But it's got big brow horns, no nasal horn whatsoever. And you look at this thing, it's like, and it's got a frill, with a big black plate, bar, like Protoceratops frills, just like Proto.
Yeah.
You look at that thing and say, well, ancestral centrosaurs have to have long horns. Because long horns are the ancestral state.
Yeah.
Sure enough, a couple of years after we named Zuni, Albertoceratops, we find these centrosaurs with big brow horns.
Yeah, yeah.
It's nice when science predicts the future discoveries.
That's what it's all about.
And it comes out. So we have good methodology.
You're not doing so badly yourself for a paleontologist.
Speaking about ankylosaurs with the their external stuff evolving so rapidly, that implies they would have had pretty decent eyesight.
Oh yeah. I think they probably did to some extent. At least they look forward and the display, the kind of spines up on the back, the arrangement of the shoulders, because they're really spiny. I'd love to see the display features, how these things interact before they pound heads. Because like a lot of animals, probably most of the time, one would dominate before they ever touched each other.
Sure, yeah.
Wander off, well, I'm too little for this, go for it,
Gonna get clobbered,
But, they're, that's why the armor is so distinctive.
Do you suspect it would have been brightly colored, too?
Good shot, the ornament, because, all dinosaurs had color vision. We have no evidence of, black and white vision. And mammals are mostly colorblind, secondarily colorblind. And primates regained it pretty early, but they never developed the pigmented retina, that reptiles and fish have and amphibians.
Yeah.
So mammals, even us, we do not see the spectrum of color they would, and have been able to differentiate as much as they would, but total color vision. So, they would make use of it. And the thing is, why are mammals black and white? Mammals became nocturnal
during the age of dinosaurs. We've talked about this many times on my channel. Yeah.
And rods, the black and white receptors are much more sensitive to low light.
And the cones are for color perception. Yeah.
So evolution, more and more rods, less and less cones.
Yep.
Unfortunately, we didn't get rid of all the cones, or we couldn't have regained color vision.
Yep. But it's
primates, ripening fruit, flowers.
Yeah.
There was all this reason for primates to want to see color.
Maybe predatory snakes very early on.
Who knows? But color, is pretty useful, particularly if you're fruit eaters and, eating flowers and things like that. You're able to see, they're right. That's why these things turn colors, is to attract things to feed on them.
Now, that's something
when the seeds are mature.
Exactly, yeah. Something that doesn't get discussed enough is that for most of our history as mammals, we were kind of under the boot of dinosaurs. For
absolutely.
150 million years. We've only had 66 million years of freedom, basically. All that time, losing color vision and, it really shaped our evolution in some really interesting ways, I think.
Absolutely. It's, it's, dinosaurs, I personally think if there was no asteroid impact, dinosaurs would have landed on the moon at least by the Oligocene, maybe late Eocene. As Troodonts, had large brains, free hands, 3 fingers, but still free hands.
Do you think they're actually getting smarter throughout the Cretaceous, though?
Oh, yeah,
you
everything.
talk about the Utah raptor having a really big brain.
You look at any lineage of animals, with time, extinction resets the clock, but it doesn't go to 0.
Sure.
It sets it back some, but locomotive adaptions improve over time. Sensory adaptions improve over time. Mental responses improve. You look at dinosaurs, the last dinosaurs, and bigger brains than the earlier. Allosaurus brains half as big as a comparable sized tyrannosaur.
Sure.
All these things are improving because if you can outwit something, you're going to survive. You're going to have babies. So we see increasing intelligence, cephalopods, increasing intelligence. All these lineages and better eyesight. Things improve. Because you have optimization. In the various characters that cause for survival.
Sure. Okay.
And of course, setting the competition. It's why our pronghorn can run so fast. It's optimization, and I'm trying to think of Gerard Vermeer's line. It's just and utilization of characters. But these things all improve with time. Humanity has pretty much stopped evolution.
Yeah, we don't have a whole lot of selection going on anymore.
Yeah, and it's and when things are good in the fossil record, when things
stasis.
are all hunky-dory, well, what happens? The gene pool diversifies because if you have a gene, set of genes that's not quite as adaptive as another, if there's lots of food and stuff, you're going to survive.
Yeah, it's those bottlenecks that cause rapid
and then when you have a bottleneck, it cringes down on you. And depending on the nature of the bottleneck, it may select for different things. A different type bottleneck would select for very different things. Yeah. But then when you decrease the gene pool, and that's the whole basis of punctuated equilibrium. You diversify the gene pool when things are good. You constrict it when things are bad. And depending on what's going on, and sometimes it's random luck. Certain genes come in emphasized, and that might happen several times before you see enough morphology that you can identify this is different in the fossil record. Yeah, but it's happening every time, and a lot of this is tied to the orbital cycles. In the ocean, the shallow western interior seaway, we see the obliquity and processional cycles. In the way the ocean get organic rich and then get with less oxygen and then not even anoxic events, just more oxygen, less oxygen, better circulation. You look at the carbonates in these cycles; they're very bioturbated. Things are happy going. Then between these things, you get these laminated shales, much fewer things. And the carbonates are all the bioturbated. That's where you get ammonites and things preserved. But it's driving evolution of ammonites. The ionoceramid bivalves. It's all these cycles, which are 10 to 100,000 year cycles. And that's probably the big driver in the ocean. Probably has an effect on land. The ice ages, are driven by that same set of orbital parameters.
Gotcha. Wobble of the Earth and that kind of thing. Yeah. Interesting.
Things are good. You diversify your gene pool, and evolution's really not operating. Things get bad. And that's when evolution goes into high gear. Select, boom. Cut them away. You're no good. You can't run fast. You can't eat this plant. And all the plants you liked are gone now because of whatever happened. It's there's so much to learn. But what's exciting is we're getting records. People used to think 50 years ago that the fossil record was so patchy. We could never answer these kind of big questions. And we're starting to realize, for the late Cretaceous, the Campanian, looking at Dinosaur Park and the Oldman, the sequence there, sequence in Montana, sequence in Mexico, the sequence in San Juan Basin, New Mexico, sequence in southern Utah. You have this, 15 million year sequence of almost complete records going up along the entire Rocky Mountain front to Alaska. And basically, we see, here's evolution of series of animals up there and down here, evolving through the same time interval, and there's barely any communication between them. you know, and now we got some models of why. Part of it is the mountain belt basically comes right up to the ocean, you know, around Salt Lake, southwestern Wyoming. So you don't have this broad floodplain. You got a huge floodplain in southern Utah. And you got a huge floodplain up Montana. And
animals can't walk across.
Nick, you know, but you got these big active alluvial fans. There's some crossing.
Okay.
But if you look down here, you know, the lineages are different ankylus. Everything's different. You know, and it doesn't, you know, people have really had a problem because, you know, I'm a biostratigrapher. You want to ask what my specialty is. So why does this correlation not work up there? It's basically you're walking along the beach, you know, with our model. And now all of a sudden you've got this place where there's boulders like this going right into marine rocks, right in southwestern Wyoming. You know, so the fans are just going right off that mountain front into the water. You know, you go to Egg Mountain and look at that mountain escarpment. That's the thrust belt right there. You know, you know, and just right in front of it, you know, it's filling sediment. Those things are nesting, you know, within miles of the mountain belt. But when that goes into the sea, you know, all of a sudden the barrier, and it's also a vegetation shift about that point. So you get different plants dominating, you know, northern Montana and Wyoming. And what you got to compare it to New Mexico and Mexico, which is more tropical. So you have two things helping separate those faunas. But they're not perfect. But, you know, where's our Albertosaurs down here? You know, we got Tetraphonius and Lythronax, and you know, we have different ceratopsians. You know, where's the Pentaceratops up there? Where's people really want that. They got to be connecting. The ankylosaurs up there, you know, completely different than ours. You know, Cainocephalus, and they got some new stuff in Big Bend near it, and the Aguja that look close to Cainocephalus, different taxa. These things are closer to the Asian stuff than the stuff in Alberta. You know, Euoplocephalus is much more derived relative to Asia than are the ankylosaurs that we get down here in the south. And that's because the link wasn't through Alaska. The link was like through Las Vegas. You know, going along the coast, and somewhere down there, they came around into the interior. So if this is correct, you know, Alberta, North Slope, Alaska are farther from Alaska than this stuff down here. And once again, it's another area for fruitful research. You know, as this stuff, as we get more and more data, you know, it really is incredible. This is the golden age. They'll say, I wish I was around the 1870s to discover stegosaurs. You know, we're making discoveries, you know, daily. You know, right now, you can't keep up with it if you're a paleontologist.
Seriously.
This is the good old days. You know, any young people who want to move into this profession, it's not done.
Definitely not. No.
I've got so many projects. You know. Like when I retire, who's going to take over some of these sites? You know, this site covers almost the entire valley floor here. You know, past our camp, if you can make out where our camp is, there's still bone coming out of this horizon.
That's incredible.
Because the fossils level is just kind of waving across this.
You could work this for a century and not
centuries. You know, constantly, and you're still not going to finish it. You know, and you go over a few miles, Lori site up in the poison strip, this level, you know, right above these beds. Basically, that's another site that covers, you know, like 50, you know, acres or so. Hanksville Burpee in the Jurassic. You know, that site is a kilometer by, a third of a kilometer wide. It's a big river system. It's like Dinosaur National Monument for
That's nuts.
Kilometer.
Yeah, geez.
That site could be worked for 1,000 years. And Hanksville Burpee, you know, the Burpee Museum that works it now, eventually, you know, they're already saying, you know, our museum has got about all it can hold. You know,
they need a bigger building.
They've got a lot of skeletons. I think they got about 8 Barosaurus, you know, skeletons.
Jeez, wow.
You know, I mean, these things take a lot of room.
You
know, and I wish we could open up some of these sites for legitimate, you know, museums outside of the country. Because the museums in the United States, you know, aren't anxious for more Apatosaurus or Camarasaurus. Because these take a lot of room, you know. You know, and you can only have so many, and keeping them in perpetuity is expensive. You know, so you've really got to think of it. The Smithsonian, you know, is shipping all their big stuff out to facilities in Virginia because they just can't keep it on the Washington Mall. You know? It's just not not going to happen. So all the big stuff, the whale collections, sauropods, a lot of the big dinosaur stuff is being shipped over to Reston. The American Museum is pretty full, so they don't mind work in Mongolia where pretty much everything gets sent back.
Exactly. They don't have to hold it there in New York,
It's, we need that in Utah. That's our biggest weakness right now, is we have so little room in collections for this stuff.
Just need bigger facilities.
I'm
and
dying
that takes money.
to get a big facility for collections in Price, Utah, St. George in the southwest, and something here in the southeast. I always figure Moab, but it might be Blanding on the edge of Bears Ears. But a big, federally compliant repository to house this stuff, and we just don't have the space. There's one, the Vernal Field House is the only one that really has a lot of space right now, and they've got that stuff.
By Dinosaur National
Monument. They got plenty up there to
stream there a couple weeks ago.
And we got so much. As people in Utah complain, well, everyone's taking all our fossils.
So many here. It's incredible.
We don't have the people. We just, it's the population that high. And setting up tourist attractions, is a good thing, but we also have to have research facilities tied to them. And we're not doing that, which is very disappointing, because I'm very close to retirement, and it's like I've tried to get more stuff here my whole career, but I hope whoever replaces me keeps up that drumbeat. We've got to have good facilities to keep fossils. We can't just put them in the basement of an old retired hospital, which is what Price has got. And they're keeping stuff good, but they're full pretty much now.
That's the thing, is it's tough to find money for repository facilities. For
everybody will pay you to go discover and dig up stuff, but to take care of it, no one wants to pay for that. It's really a problem. Preparation, preparation, clean the fossils. Well, that's not sexy. You're out here camping, fighting off rattlesnakes and coyotes. We'll fund that. But there's no follow up, and it's really tough. I dream of a field station in Green River on the old White Sands launch facility.
Oh man,
millions of dollars of infrastructure just rotting. And it's like, man, we could house 100 students there. And they'd be within 100 miles of so much stuff to do research on. In archaeology, biology, geology, paleontology. This stuff is as good as anything on planet Earth. And because it's local, no one seems to think it's important. Well, I want to go to Argentina. Or I want to go to the Gobi. It's like, this is every bit as good as the Gobi. And we get sandstorms here every bit as good as the Gobi, too. I guarantee it. I've been in both. And we have sandstorms here that are just as nasty as the ones in the Gobi.
Well, what were you saying about those Chinese researchers who were saying that Utah was the key?
Oh, yeah. I've given tours to groups from the Chinese Geologic Survey through Utah and Plateau, northern New Mexico, and stuff, focusing mostly on Utah twice. And their top people at the Chinese Geologic Survey, and I did it on my own time. Utah didn't pay for this. China paid for this, and I took vacation time and did it for free because they don't like us moonlighting. But China's treated me really well over the years, and the Chinese are just like shaking their heads, like, obviously, this should be the keystone for paleochronology and biostratigraphy for terrestrial realm for the entire northern hemisphere, because it's the only place where we have a complete record in one place with ashes and marine tongues sticking into it. You look here and you see half a mile of marine mud.
That's nuts.
But as you go down the Grand Staircase, the straight cliffs, on the east side of Grand Staircase, but the Blue Gate, the stuff above, that first escarpment, the Juan Lopez, that whole pile, that's stacked beaches for that whole sequence. And you go further west, south of Bryce Canyon, we get dinosaurs in those ages, and they haven't even looked at yet, south of Bryce. And if you go down to Cedar Canyon and the Pine Valley Mountains, this lower cycle, which goes all the way through Grand Staircase and further. We have terrestrial sequences there with dinosaurs. We found part of a little maybe a Tyrannosauroid, a big block of fallen sandstone. It's now at the University of Utah. But we have these virtually complete record of this stuff across the state, and there's plenty to be done, which is the best part of it. I mean, I want to be dead and gone, and the next generation of folks and the next generations are going to have plenty to do. The book that's barely been exposed. We got equivalents of Dinosaur Park Formation. I remember crossing a pass right near the border with Colorado and going back in there, and it's just like, far as the eye can see, Campanian Badlands.
Oh,
and
man.
it's like, nobody's ever looked at this stuff, ever.
Yeah.
Just, and then, above that, the Eocene Badlands. But there is so much. The new paleontologist at the Prehistoric Museum or Utah State University in Price, he's starting to explore and he's finding sites. Yeah, that's a surprise. I worked up near the border one time. One day they wanted to show me a hadrosaur that a young woman found looking at petroglyph sites.
Sure.
And, it's a hadrosaur, and we poked around. Found 11 sites before lunch.
Holy cow.
It's like,
11 different spots. Yeah.
Both microsites and skeletal sites.
Yeah.
There was one place where there were hadrosaur verts laying all over the ground. It's just like, oh, man, there's just more than you can do. Which is, for the young people, listening to this, don't even think it's all been done.
100% it hasn't been, no.
We're just starting to figure out what the interesting questions are. Jurassic Cretaceous boundary, the Aptian extinction, the Cenomanian, Turonian, the Asian immigration-induced extinction, and the dawn of the Upper Cretaceous biota of North America. Those things all need more work. And I know North Carolina is looking at Mustn't Touch It, because that records the Asian immigration event.
That's Lindsay Zano stuff, right?
Yeah. And Pete McAvicky's still working out there, too.
Cool, yeah.
So the Field Museum of North Carolina, Museum of Natural History. Everyone goes, well, Jim, shouldn't this all be yours? All of Montana is Jack Horner's. It's like, no. I do not try to make this my exclusive playground.
Yeah, you couldn't. I mean, there's too much. It's incredible.
Well, if I tried to do that, and I'm not saying other people might not have, tried to do that, it's just a detriment to generating this human knowledge of what we've got to work with out here.
Yeah.
There's so many exciting things to discover. Now that I'm getting, up in my later 60s, just, dang. What's going to happen? This site, when we stop working here, there's no one that's wanting to jump in and take over and just keep working here. This is a giant site. And, we talked about the stuff Ewart Canyon. All these Coniation and Santonian dinosaur sites. It's like no one is, we went in there for a week and dug up half a new hadrosauroid out of the Coniation, and you park about 50 feet from the site.
It's a dream.
Yeah, there's just so much. I do there. The whole Markagunt, Ponzagunt Plateau have barely been explored. Grand Staircase, the Parowitz Plateau, takes all the energy down there. Because there is a little money tied to that monument that funds, has funded some of the Denver Museum's work. And now they're stopping work down there, focusing on the Denver base Cretaceous Tertiary boundary. It's like what institution is going to be the main player in Grand Staircase? It might be the Raymond Alf Museum, which is a museum tied to a high school. Tied to a high school.
That's great.
Yeah, but they're probably the only group, going down there doing dinosaur paleontology. And turtles,
Yeah.
I mean, they put a picture up. They got complete turtles with eggs in the body.
Oh, man. Gravid turtles.
These things, these baenids that have armored feet. They have these big osteoderms. Like, what are they doing? Climbing trees? What are these things? The fossils down there, half their animals have skin on them.
That's incredible. Yeah.
And that's like Mexico when we were digging there. We found dinosaurs with skin, hide preserved, that had oysters growing on the skin. So just solid salt, cured, carcasses that got flooded and oyster spat. They were intertidal.
That's nuts. Wow.
And survived long enough. The oysters are just spat, but like a centimeter across. It's like, that didn't happen in one day. Oyster spat's almost invisible when it lands.
Gifted Muscaling a subscription.
Sitting there for a long time.
Gifted a tier 1
it's
sub
funny,
to
the first
Muscaling.
dinosaur discovered
They
in the
have
Rincon,
given
Colorado area.
148 gift
They
subs in
collected
the
the
channel.
bones, and we rediscovered the site, matched up pictures. A little Ocotillo, 25 years later. Don't look like they've grown a millimeter since then. The same little crook, just lined it up. It's like, that's it. And they left behind the skin.
Wow.
They found a dinosaur up there, the raptor, Rhino Rex.
Yeah.
They missed the skull just because it was in a hard nodule and stuff. And, but they collected the bones. Someone went in there, raided all the bones. And they left this incredible dinosaur skin behind.
Oh, man.
Plus, they don't have the search image. Yeah, that was a dinosaur mummy you guys destroyed. And it happens. Skin is one of the things that many poorly educated professionals too.
Yeah, if they just don't know what they're
blow
looking
through
at.
the skin.
Yeah.
Going for the bones.
The number of stories I've heard of like prep labs where they just prep the skin off because they don't know what they're doing.
Yeah.
Don't know what
Yeah,
they're
that
looking at.
stegosaur, the Bolan stegosaur, they just prepped all the skin off that one.
Yeah.
Off the legs and stuff. There was skin on it. I saw
All
it.
that knowledge lost.
And it was the amateur volunteer preparators, and they chopped through all of that stuff. It's basically, there aren't that many really and when a museum is like hurting for money, the first persons they lay off are the preparators.
Those are so
these
essential.
artists.
We couldn't do what we do without
artists.
preparators.
Yeah, people that, some folks like Scott Madsen and, what is it, Amy Davidson, at the American Museum. Some of these people, Bill Amaral and Chuck Schaff, they're artists, doing this, and, when you're in the field, you want to leave a lot of rock around your bone and things so they can do it right and see if there's any things. And as we've worked the Utahraptor block, we found pieces of what are probably, juvenile theropod skin.
Really?
And we got a claw there. Yeah, it's being worked on by Rachel, describing the skin.
Okay, cool. Yeah.
We SEM'd it because it's so beaded, it's these little beads. It's only about that big across, but it's clearly skin. I was wondering if it could have been some kind of, lizard or, Albanerpeton, which is an amphibian that has little osteoderms in the skin. But they micro CT scanned it, and there's no bone under these things. So it's almost certainly dino skin.
Wow.
So she's describing this little piece of dino skin. And you do, you dig in a site in a mud hole, like the Mygamore Quarry.
Sure.
And we found, when I was working there, a patch of allosaur skin. And then, John Foster described later, because he also found a patch of sauropod skin. Just chunks of rawhide buried in, this bone bed. The Tibbet Springs Quarry down Grand Staircase. We had this hadrosauriform skeleton. Still an important site. It's just no one's working it now. But right now, we're digging and got a patch of skin. It's loose. It's just buried in the sand. Yeah. Something ripped it off and tossed it aside when it was scavenging the carcasses. There's a lot of dinosaur skin out there. The sheath on the claw of one of our mantis claws of the Utahraptor block, you can just see it's kind of slid down.
Oh, beautiful.
It's got the
You've got the keratin there preserved?
Yeah, it's a ghost, but you can make it out.
How long is it? Does it make the claw like a third longer?
Yeah, it certainly makes it longer. They're pretty hooked. I mean, they're hand claws on Utahraptor.
Yeah.
Nice hooks.
Big old meat hooks.
Yeah.
Yeah.
And we're thinking more and more, because the claw is pretty straight. It's not as hooked as some of these things. That they have incredibly powerful leg muscles. The legs are 50% bigger around than the same size Allosaurus.
Wow.
They're massively built with big muscle attachment.
On formal occasions,
these
he's
things are
called
probably kicking those claws into the side of
fella,
animals.
isn't he?
Like climbing
70
spikes.
feet long.
Just
Tips the
people ice
scales
climb,
at a
they just kick on their
substantial
spikes.
35
Yeah,
tons.
yeah.
And I think these things just kick in and just climb up and get on, get up to the neck and start trying to reach over and rip the neck out. Because how are these things defeating, a sauropod? If they get on the back, sauropod, people, Well, wouldn't it drop and roll to get rid of the dromaeosaurs? Sauropods aren't dropping
Certainly,
and
there are
rolling.
many more
They can,
dinosaurs waiting to be
they're
discovered.
standing there, and
Many new
I don't think
mysteries
they
waiting
ever
to be
lay
proven.
down.
Huh.
I think you got, they
You think
somehow...
they sleep standing up?
Oh, yeah. Yeah, they're not built. You look at the flexibility of those guys.
Uh-huh.
They're not getting down. They're,
Huh.
they're standing up much more so than an elephant. You look at the nature of the joint. There's a lot of cartilage we don't see.
Yeah.
But,
Interesting.
yeah, I don't see those animals, the big ones. Maybe young animals can do, things.
Yeah.
And I'm not against diplodocids rearing up.
Sure. Yeah.
But laying down, I think, would be a real tricky endeavor. And there may be a way if they somehow slip and fall. If it doesn't kill them. An elephant falls a couple feet, it kills them.
Yeah.
And sauropod falling a couple feet should kill them.
Yeah.
I mean, they're not built for that kind of thing.
I mean, proportionally, they'd be lighter than an elephant, though, right? Because they've got all that pneumaticity.
Well, it's not that much.
Yeah.
They got pneumaticity, and it does light, like particularly the neck.
Oh, yeah.
The ponderous
It's considerably lighter. Some of
32
those roads,
feet long and
sealed off
14
the openings,
feet high.
filled it with helium, would probably float.
1,500 feet.
Sauropod vertebrate balloon.
For titanosaurs particularly. The more primitive ones are more solid. But I think it's just to make the neck head function better. Because the pneumaticity doesn't go into down the tail.
Okay.
On these things, and they're in the vertebral column, but that's also tied into their breathing system.
Yeah.
To some degree.
Bird respiratory system.
Now that's the kind of questions those like pin Matt Weddle down and say, Matt, let's
Carrie
talk
Woodruff,
about, let's talk about pneumaticity.
Yeah.
And these guys, Carcharodontosaurus. We got down south in the Cedar Mountain, we got this Carcharodontosaurus skeleton. We got too late, so we got a good cervical and part of the sacrum.
But the rest was eroded.
Yeah, it was like right on this ridge crest. So the rest of it had gone. But it was an animal, and we had a young woman work on it. But it was, at first I thought it might be dromaeosaur because it was just like a T-Rex, totally pneumatic.
Yeah.
Almost there's so little bone in that cervical. And what it turns out is Carcharodontosaurs are hugely pneumatic.
Yeah.
Where allosaurs aren't nearly that pneumatic.
Okay.
One of the things that really sets Carcharodontosaurs, they're allosauroids, but sets them away from allosaurs proper as a discrete group. And, that animal is a Carcharodontosaur for sure. And that would have been in the upper, there was Upper Albion. It was, high in the Ruby over there, about under 3 million.
Sure.
They're very different than allosaurs. Pneumaticity that compares, with compares with tyrannosaurs independently, developing that level of pneumaticity.
That's pretty cool. Like once you're a theropod and you reach that kind of size, it just sort of happens.
Had a little antelope ground squirrel coming and check us out.
Oh, do we? Where is he? Oh yeah, I see him
right there.
He's coming up behind the camera.
Think we dropped any food for you? Yeah.
Little chipmunk looking guy.
That's an antelope ground squirrel.
That tail,
Yeah, the white tail over the butt. Like antelopes have a white butt.
Wow. And he's got those stripes down his side.
Oh yeah, no, they're related to the chipmunks, but it is an antelope ground squirrel. You really, and the one in camp is not a chipmunk; it's an antelope ground squirrel.
Gotcha. Very cool.
Yeah, they're doing better out here than a lot, but there's quite a few kangaroo rats. You see these little banks that are full of holes.
Oh yeah,
that's a kangaroo rat.
That sandy habitat.
Colony, because they're very social little animals.
I've heard stories about sandy roads up in the Hell Creek where they'll drive at night and they just have to slow down to 2 miles an hour because it's just crawling with kangaroo rats, just like a living carpet.
Neat stuff. No, it's the small animals, pack rats, kangaroo rats, mice, antelope ground squirrels, the small animals, of course, cottontail rabbits, jackrabbits, a lot of animals. But right now, we've been into this drought for a while, and the number, you have a couple good years, and all of a sudden there are rabbits everywhere. And this year,
I haven't seen a single one except on the field trip.
The jackrabbit, field trip. I've seen a couple. Yeah. But I've been in this valley when there are little bunnies everywhere. And of course, that makes the coyotes happy. But we are in the amount of wildlife in here right now is because this has been our home every summer for 14 years.
Let's talk about that. Like, how long have you been coming here, and how did you first get started in this area?
Well, I first came into this area, Helmut Doling, the second hired UGS, mapping geologist.
When they hire him?
1952.
Wow. Okay.
Yeah. He's like 60 years mapping Utah.
It's crazy.
Mapped this whole region. And I knew they were doing a map that covered this area, a geologic map. And I was working up by the road there, Yellow Cat.
Yeah.
So I wrote him and said, is there any way I can get a pre-copy of that geologic map? And he sent me, color Xeroxes, 8.5 by 11s, just taped together the whole Arches region. And on the map,
man.
I see this thing with a road coming in, and it's all mapped as Morrison under, Cedar Mountain, where this used to be thought to be the base of Cedar Mountain.
Sure, yeah.
And I'm like, there's going to be Yellow Cat in that bowl. And drove in, and as we were hiking, well over on the flats toward camp, we started picking up ankylosaur ossicles, guanodont teeth, fragments of sort of big, broad sauropod teeth, enough that it's like, okay, this is early Cretaceous. And I was thinking, at that time, very early, a year or two after our first discoveries. So I'm thinking, this is just about the level as over there. I'm thinking the chert, I knew we were above that chert level. The chert's just a silicified calcrete. It's just chert instead of carbonate. So I didn't think that much of it. There weren't any skeletons obvious at that point.
Yeah.
But, okay, this is Cretaceous here. And basically we're back over in the Elmweed working Andrew's site. We had
around what year was this?
Well, the first time I came in here would have been like 91.
Okay.
Discovered those, sites.
Sure.
And then we were back in here in 2005. On that we hired, got that site reported to us. And actually, Andrew Milner reported to us. Andrew and I went in there, couldn't find any bone. Couldn't find anything. And I go back in there, and because it's a good place to stop and talk about the vista.
Sure.
Where that road cuts through is an old oil pad there, as you noticed.
Yeah.
So we park on the oil pad, and I look down, and there's bone everywhere. I go, where were you a month ago? As there are two levels of bones there. Right on the side of the road. It's like, where was this a month ago? Did someone come in and just pick everything up? And as I told you, that lower level had been picked clean.
Yeah.
Now there was more ankylosaur stuff coming out of it. And that might have been going on with the upper site. But anyway, gone there, and that's where we found the type of Hippodraco and cedar cephalodon. Got a new croc we're still working on naming. A little terrestrial croc, about probably that long as an adult.
Cool.
That big. Basically the role of a raccoon in the landscape. These little bunny crocs running around. They're smaller four-legged carnivores. But we're working on that site, and we had a student from Temple University, in Philadelphia, from India, and he was from India, coming over working, and he's looking at the sequence in those rocks and trying to do paleoclimatology. And I'm looking at it, looking at the cherts, and I'm like, these look like those same cherts over there. So I drive over here, because it's only a few miles straight line, but it's about a 7-mile drive back and forth. Drive over, it's like, all that bone's coming out. That's the calcrete. They're coming out below the calcrete. That's what we were using for the base of the Cretaceous. This is clearly a Cretaceous fauna. Back and forth. I mean, in a few days, I probably did that trip back and forth 20 times. It's like, dang, those faunas are older, clearly, than anything we've found so far. And I come over, finally bring Don and Scott Madsen over, and we're looking, and I found a Gastonia-like plate, probably, this new animal I haven't named yet. Plate in the rock, clean it up, collect it. These guys, prospect, they're going along the sides of the bowl.
Sure.
So, they're not really finding anything prospecting the sides. And they're coming over and they're standing by me, tapping their foot. Let's get out of here. There's nothing much here. And finally they got so bored because, it takes a while to dig up something properly.
Yeah.
So they go back wandering, and then they're coming back to me, like kind of giving up. And Scott's walking through here, Don's walking through more out by the road. At the same time, pretty much, not knowing each of them, just like, oh, there's bone here. Scott found what we call Scott's place. Don found Don's place, which was Yorgavuchia weathering out. Scott found some iguanodon stuff coming out. And they were digging around there for about an hour. And they both stand up and turn and see each other and realize we're on the same horizon, and we're about 100 meters apart at least.
This thing extends all through there.
This thing's going through here. So they come over and say, Jim, you got to come over here and look at this. And holy cow, the skeleton. That's the same level. There's the cherts. And it just kind of, swales through here. And under our feet, there's probably more skeletons at that level. I expect under all the dunes here. Below us, that site just keeps going, and okay, are all the skeletons washed up there? But as we've dug that site, we've discovered, the cherts, which have fern roots in them and whatnot. That we finally come to the conclusion they're silicified peat beds, and like petrified wood can get agatized, peat's pure organic material. And the peat's being silicified. And some of it just pretty agate, like some of the logs of petrified forest. You don't see tree rings. Others are beautiful for it. It's the same here. The peat, some of it's just agate, and then others you can see the fabric and the roots in it, the ferns and things. So it's like, okay, this is silicified peat. And then as we're digging in this site, realize there's chunks of fern root as pebbles in the site. This is forming like 2 feet below us as it comes out. So this stuff is, coming, is forming right at the surface, breaking, partly silicified, breaking up, and becoming pebbles in the unit. Really interesting that the silica is happening right at the surface. And probably the source of the silica, is the underlying Morrison Formation.
Just
which
being
is
reworked.
Very full of volcanic ash, which as it breaks down into swelling clays, releases silica into solution, which saturates really quick. And once it becomes saturated, supersaturated, it wants to come out of solution. So that's why silica just starts permineralizing everything. And as it comes out, then it becomes more undersat and more silica can move.
Because we've been finding tons of silicified roots and stuff like that in the quarry, and I'm not used to that. That's
no, it's really an interesting story. And as we've prepped, on this stuff, realizing, there are mats of roots here, and we do see root traces that aren't silicified there as well. That these things probably annually or more, throwing up big fronds off the roots. There's modern ferns that do that. They have pretty thick roots and are putting up the fronds off the roots. So we see that, and talking to Don Tidwell from BYU, the great paleobotanist of the Morrison, and Upper Cedar Mountain. Basically, he identified the fern's roots as Tempskia. And Tempskia is a really weird fern that builds a pseudo trunk out of roots, sending fronds, and they can be 20 feet tall. I've seen them this big around.
So different from like a modern tree fern.
They're not a tree fern because they're just pseudo roots, and ferns just coming out randomly on this big pseudo root stem, and we found a few in there, but he identified the initial roots as Tempskia, and I said, well, they're horizontal. We have them articulating, we see they're branching, and he's like, impossible. But this thing is probably the ancestor of Tempskia. Because it's like 40 million years older.
Wow.
Because now we know this. We didn't know that then. But so there's plenty of time to evolve into Tempskia from this type of fern. And we actually found some hollow Tempskia-like trunk things when we were digging up around this little articulated iguanodont. Several of them. And they're jacketed, and I'm really wanting to have a paleobotanist work on them. Because that may be the first example of these things developing this stem. But they're only a couple feet long. And apparently a hollow because they're really flattened.
So they just get squashed flat like a cardboard tube.
That's what I think is going on. But we need to collect these, harden the heck out of them, cut them. And paleobotanists like to cut things up. But dinosaur guys are starting to do that a lot too.
Histo, got to do it.
You got to do it. You got to cut up some of these bones, but cast them first.
Like Jack Horner always says, glue is cheap.
I know. Getting that info, and for these, the growth series, if this was Guana colossus, we basically have ones with femur femora this big. So we have some pretty young animals, so we can really look at iguanodont growth relative to hadrosaur growth in this population. And a young woman started this project. Unfortunately, her PhD program, she kind of crashed and burned. And she's teaching now, like junior college level. And she still, hopes to get into another PhD program and complete this project. But since she did her stuff, we found a much bigger, femur that should be cut.
Nice.
So because all the the cut sections are all curated at the University of Utah.
Gotcha.
So this stuff, it's not like we lost this stuff. Because Dawn did all the casting and molding. We were very helpful. We're kind of sad that nothing came of it yet. But, we're really hopeful that eventually either she'll continue or someone else will pick up on the project and add to it and do a thing on the growth history of this animal.
Yeah.
And someone needs to study this animal.
Yeah.
Karen Poole at, New York, State University of New York at Staten Island, I think. She teaches anatomy there now. She did her PhD on iguanodonts from Africa and whatnot, and her master's on one from the Utahraptor site, which was like the back end of an iguanodont. I've always, I've known Karen since she was like 16, and so I was hoping Karen would do it, but it sounds like she's more likely to be helpful to someone, younger doing it. She's come out here and dug with us a couple times, and I wouldn't take the project from her yet.
Yeah.
But Karen's the type that I think someone said, I really want to work on this.
She'd let him do it.
Yeah.
Yeah.
We had a British iguanodont student come over and spend a few weeks looking at our collections, and she was totally okay with that.
Cool.
It's like, talk to Karen.
Yeah.
We're okay. We want this stuff studied.
Exactly. Yeah.
Yeah.
Stuff that we've been digging up for the past almost 2 weeks now.
Yeah, and 14 years for us.
14 years.
But when we were coming back and forth, those guys found that thing and changed everything. I mean, it really did. And now over Utahraptor Ridge, which that the Utahraptor mass is up in the upper Yellowcat. Okay. Well, above the calcrete. Down at the bottom in those ironstone nodules that ironstone paleosols that sit just above the base of the Morrison Formation, which shows that surface between the Jurassic and the Cretaceous that represents some millions of years was very wet. Because no carbonate, which is a salt, all flushed out, and we get iron. And it's like, that's wet. And we see that in a few places, in the top of the Morrison. Most of the time it's scraped off. But we do have at Utahraptor Ridge some ironstone in the Morrison. And at the base of the Cedar Mountain everywhere. Yeah. And old papers, like 2004, a paper on Morrison paleosols, seeing those same kind of things into what we now consider interfluvial beds of the Buckhorn River system. They thought there were hills between the river system with Morrison paleosols that had iron. But I've studied these, and I've seen how they interfinger. That we now know it's basal Cedar Mountain. But it was very wet in that basal stuff, but it's just stacked soil, very slow deposition, but wet with iron. Does that unconformity relate to, and also, the mountains were very subdued there for that time interval. And is it because we had Pacific, wet air coming in, and southern wet air coming into this area without any mountains to, screen it out? Sure. Because once we hit the calcrete, we start getting carbonate, and the stable isotope people are telling us, all the evidence, we look east and west on those horizons, suggests we're looking at a rain shadow. So the calcrete seems to show the beginning of the rain shadow for the beginning of the uplift there. Yeah. But this Foreland Basin, the big mountain range pushes down. You got a big trough in front of it that fills with sediment. We don't see any evidence for that until like 25 million years later, in about the middle part of the Ruby Ranch. As the lower Ruby Ranch is over here, all over in Cloverleaf, goes over there and it thickens to, a couple 100 feet thick. And over there, it goes up, and we know the upper stuff is late Albion, post Cloverleaf. So somewhere in between is the Cloverleaf age. In there. And then the mustn't touch it is only over there. Those are Foreland Basin things, and by the time we get into the Foreland Basin, look at teeth. Selena Suarez did wonderful work looking at all our stuff here and the stuff over there. The teeth here show no evidence of change in the water oxygen isotope ratios, but once you get into the upper Ruby Ranch and the mustn't touch it, we see a flush of light oxygen isotopes in the teeth as the enamel's forming, and that suggests there's a spring runoff of snowmelt. So we think by the time we start a Foreland Basin, there's already snow on the severe mountain belt over there.
You could tell that from dinosaur teeth.
Yeah,
because so cool.
You are what you drink.
Could you explain that a little bit to the viewers about oxygen isotopes and how that works?
Yeah, both. We use what we call stable isotopes. You hear about carbon dating, things like that. We're looking at carbon-14, which is radioactive. It's not stable. For dating young stuff, 50,000 years or younger. It's got a half-life of like 5,000 years. So not very useful on these rocks. But when we look at the stable carbon isotopes, 13 and oxygen 12, organisms metabolize that stuff differently. And the lighter isotopes tend to metabolize quicker than the heavier ones. So, during the Cretaceous, the thing we started this whole process on here, there were periods, during the early Cretaceous, periods when the oceans went anoxic. And that's when a lot of the world's oil was, oil source rocks were deposited.
Because all the microorganisms were dying and
plankton and whatnot. So you start burying all this light carbon on the sea floor, and the oceans basically die till about 500 feet. That's why we don't find deep water trilobites, because there was no oxygen in the deep ocean. So you had huge extinctions during this interval, repeated, dying off of the deep ocean. But that's buried so much organics that it drove the oxygen, the carbon 13-12 ratio in the atmosphere differently. And we see this in these carbonate-rich soils in the Ruby Ranch and whatnot. And the groups I work with that are doing isotope work use that, what we call chemostratigraphy, and supplemented by a few radiometric dates or biostratigraphic markers. They match the curve of carbon 12 to 13 and compare it to the ocean, and it's a global signal. So you can,
no matter where you go, you can still pull that out.
This kick in carbon is related to this, oceanic anoxic event, OA 1A, and here's 1B, and and they correlate this stuff. So we're trying to date these rocks to begin with. And oxygen isotopes, which you also get in these carbonates, and this is kind of how we figure out the rain shadow effects, is comparing it with the oxygen in the same rocks. If we look at dinosaur teeth, they don't have carbonate in their teeth. It's fluorapatite, so it's they're phosphates. So you get oxygen. And basically the oxygen isotopes are reflecting the water they're drinking. And when you have O18 and O16, the lighter ones react more rapidly. Also, when you're making rain, you start, the heavies tend to go out. So you end up stockpiling up in the mountains in the snow, light oxygen in the snow waters. And since that's stockpiled up there in the high elevation, when you have the spring melt, all of a sudden you got this big kick of light oxygen coming into your river systems, feeding off of those mountains, and that's reflected in the oxygen isotope ratios in the enamel. The teeth enamel is very stable, and they sit there and micro drill these teeth. You want reasonable sized teeth, and chilosaur teeth aren't very good for this.
Too tiny.
But big carnosaur teeth, the big sauropod teeth, the best. They look at this, and in an environment where you have a spring melt off, since these big teeth take a bit more than a year to grow, all of a sudden you'll see this big light thing in these micro samples. And our big teeth there, they've sampled a lot of just tiny little things on the scope. They've been able to show that once you get up to the big teeth over there, here it shows no evidence of it. You get into about the base of the Albion, the last stage of the early Cretaceous. You start seeing the evidence of a snow melt off each year.
Very cool, showing that there was a mountain range there that actually accumulated snow.
Yeah,
That's so awesome.
And people say, well, how could you do that in Mesozoic? The snow cap on Mount Kilimanjaro in Africa is right on the equator. It's about dead on the equator. So when you have a high enough elevation, even in a warm place, you can get snow.
Nice.
That's why I think the ancestral Brooks Range in Alaska, which formed in about the Albion, tide, because we had no animals coming from Asia, went straight across there. Probably it was a continental collision forming that mountain range, the ancestral Brook Range. Yeah. So right on the equator, multi-miles high, there was an ice cap on it. And the North Slope, of course, comes down to near sea level on that side, and then you got the Pacific side. I think the animals, in that mountain range goes right into northern Siberia without a break. So, if they have to find a way around up in Siberia and go along the Siberian
all the way down
coast.
South, and
the easiest way to come over here is follow the southern warmer stuff along the coast, the lowlands, shedding off of those toward the sea, and make it around, and probably around Vegas or somewhere down there.
Sure.
They got around the severe thrust belt, mountain range, and were able to come up along the side of the seaway. And with this nice evolutionary pinch-off point in northern Utah. Southwestern Wyoming.
Yeah. Very cool.
Yeah, it's
pretty amazing.
The stories are starting to come together.
Yeah.
We need a lot more data. These are hypotheses, but they're testable.
Yeah.
And we're seeing more and more that the southern stuff here seems to have the closest ties to the stuff that we see in China and Mongolia.
Very cool. Speaking a little bit about, I guess, obliquely related to the chemistry of that, maybe talk a little bit about animantarchs and about your experiments looking for kind of radiation as a clue as to dinosaur bones. Yeah.
Well, one of the things, the Morrison, we have very radioactive bones. Uranium will replace calcium, and the calcium phosphate very readily. Uranium phosphate's a pretty stable form of uranium ore. Yeah. So the Morrison, all the volcanic ashes was breaking down, released all the silica, but also released uranium in solution, which permineralized a lot of logs, comes out of solution once it hits an organic rich area. So just they mine a lot of uranium out of the salt wash part of the Morrison. Yeah. But bone in general will absorb uranium preferentially just because of the way it replaces calcium ions. So basically, this guy Ray Jones, from up at the University of Utah, he's a radiologic technician. He decided to try to prospect for fossils using radiation levels and using an old lawnmower chassis, and he put a Geiger counter with a big lead shell over it, so it was only read from the ground. When he turned it on, he just tipped this thing forward and flush to the ground. So all radiation it's detecting when he turns it on, it's coming from below, and then he'd write down that number, go another couple feet, do it, and grid off whole areas. And he decided to try it on a site that was found by his wife. Carol found this site where Eolambius, Carol Jones eye. Feminine, singular, because she found the site originally because they had a home not too far away from the mustn't touch it stuff. And I was looking at this thing, and probably that's when we first figured out Eolambia. So I want to take this my machine he had invented over there and grid out that whole big area. Sure. And he did it, and he said over there, after he massaged the data in the computer, extracting background, things, he said, you guys should dig over there. So Don Burge and his crew dug over there and came down, no bone exposed whatsoever, about 1.5 foot down. They had a skeleton of an ankylosaur, nodosaur.
That's crazy. That's animantarchs, right?
Animantarchs, Ramal Jones. So, Ramal, or Ray Jones, as we all know, Ray Jones and Carl Jones, both have dinosaurs named after them. Wow. The same quarry, for two different reasons. But that was it's still, I think, the only dinosaur purely discovered by technology.
Yeah, and that seems like a pretty lucky shot. I mean, it's not, that sort of stuff's been tried before, and it's...
Yeah, well, they found the skull of the type Jimatsonai. Ray found that, took his instruments up there. They had no head. The head had washed farther away than the skeleton. Yeah. So he was mapping the area with his radiation. He says, you should dig right there. And Scott Madsen pulls out a pick. He's going, no, it's pretty shallow. It's got tapped, and the rock just peeled in. There's occipital condyles.
Oh, man.
You know,
back of the skull,
half an inch under the rock. You know, but he wouldn't have found it.
Yeah.
He took it up to Hagerman fossil beds, which are Pliocene.
Yeah.
And, you know, the bone is white. You know, dark bone, you know, you can say, okay, that's part of that darkness is uranium. And the stuff in the Cedar Mountain is not dangerous. It's got very low, practically no radiation at all, just enough for some of this stuff to work. And basically, the Hagerman, in that season, you know, the bench they'd exposed down above the bone bed, he mapped that whole area. And he basically told them where every skull would be, and there was a skull every place.
Really?
He said, yeah.
Wow.
And that worked at Hagerman. You know, so this technology, you know, has legs. But when he stopped doing it for us out here, no one else, you know, jumped up and started applying those technologies.
So you think that could become like a standard method in the future?
Yeah, particularly when you have like sites like this. You know, where it's really, you know,
nice and flat,
not much overburden.
Yeah.
You know, because if you don't see a dinosaur, you don't start digging till you see some bones.
Exactly, yeah.
You know, and definitely Anamantarx, you know, was the only, you know, we would never have dug that spot. You know, and even though it was only a foot down, there was no evidence there was anything there.
Sure, yeah.
So, you know, that was discovered by technology. But seismic stuff, you know, I worked with the Department of Energy for part of a summer when we were digging over in western Colorado at the Mygat Moore Quarry. And, you know, they're doing, you know, gravity surveys and, you know, electric resistivity and trying all kinds of different techniques on it.
Sure.
You know, gravity, you know, detectors, you know, because the antenna, again, is, you know, different size. They got different penetration. All the different equipment. And they made maps and said these should be where bones are. Nothing. In fact, there was a big sauropod limb we had uncovered partially. It was kind of coming out. They bounced it over this thing.
And nothing?
And they couldn't see the difference. Because the problem with most of those techniques is the density of the bone and the rock that's around it. It's way much. It's very similar. You know, those gravity and stuff work really good for archaeologic sites because the whole fabric of the ground is disturbed by the people.
They're working in soil, not rock.
And it works pretty well. You know, so you can find you know hidden villages and things. Just because the way people make North Africa under the sand dunes, they're flying over and be able to map all these things.
Cool.
Roads across that area. Tom Bound did a lot of early work on that stuff.
But the seismic stuff didn't work at all either. Like,
are you a fan?
I mean, viewers would be familiar with, like, in the movie Jurassic Park, they've got that shotgun shell thing that fires into the ground with the sonic imaging. Nothing like that.
No one has ever found a bone using that methodology. And what's interesting, though, you look at the fabric of the rock. Rock layers. Here's the sandstone layers. So you can map three-dimensionally. But that's because of the density differences between the different types of rock. But it just doesn't work for fossils at all. No one has ever found a bone with that methodology. So the whole we're going to soon be stopping. Looking at the image, you see this whole skeleton. Like, believe me, guys. What I was looking at when they did the stuff there was a very vague, full color map of different reflections, and there was. It was almost like negative data. It's like, oh, if you dig there, you will not find bone.
Yeah.
Man,
yeah. We can wrap this up if you're getting kind of hot.
No, it's not hot. I'm just had a little sunscreen in the eye.
Oh, shoot. Yeah.
Part of the hazard, and this is supposed to be.
Oh, yeah. Occupational hazard out here, for sure.
It normally doesn't happen.
No, I've been kind of amazed at just how hospitable this site has been compared to like the Hell Creek or the Judith. Like almost no insects up here, no biting flies, no mosquitoes.
Oh yeah, I mean, if you were working here in October and November, which is the best season, that's also when we have our meetings, schools in operation. It's ideal. It's a little nippy at night, so you get in your sleeping bag.
Sure.
Where now it's you don't need a sleeping bag. Out here at night.
Oh yeah.
And it's plenty hot during the day, but in October, late September, October into early November, it can be totally beautiful out here to work. And that's when you want to prospect. That's when you want to be hiking, looking for new sites. Because when it's 104, hiking over this country looking for sites, you're sweating so much, and you're so hot and tired, you miss sites.
Yeah, for sure.
And
it's tough.
But if you're then you're comfortable and you can really motor, without totally suffering. That's when you find the good stuff. And we go out. The thing about this region is on any given day, if Don and I are out prospecting, we can find a site we can spend the rest of our careers on. We can do that any given day. And that's so we don't do a lot of prospecting because we work in the sites we've got until we drop dead, and then who takes them over? But there are so many sites out here to be found, and some of them are pretty dang subtle. This one was the bone, where we got the skeletons. Was almost more of a stain on the mud. The bone crumbles to dust as it surfaces.
It's tough to find.
You're not finding just chunks of bone on the ground. But as we've worked this stuff, we found there's bone everywhere. We've done trenches, and and when they do cut a road through this stuff, you realize there's lots of bone in this stuff. There's a lot of sites, and there'll be lots of sites into the future. So this region, these rocks, it's we got a 45 million year early Cretaceous record here.
That's nuts.
Prior to that, we had
years.
one level of early Cretaceous in North America, in the Arundel in Maryland, the Paluxy in Texas, the Antlers in Oklahoma, Cloverleaf in Montana, northern Wyoming. That's all lower Albion. It's all pretty much the same age. And now here we have 6 faunas, and between fauna 5 and 4, there really needs to be a cloverleaf fauna in between, because we're not catching that. And now that we know dinosaurs, species of dinosaur will go more than 500,000 years. They evolve as rapidly as mammals, except you can't ID them on a single tooth. So you need a skeleton, or at least a skull to identify some of the species. We realize that this is a 45 million year record in the Cedar Mountain. And when we started, there were only 2 dinosaurs noted. One was actually an animal from the Morrison that was identified by Dave Weissample as, someone sent him some, all very juvenile stuff. So it's from the Cedar Mountain, early Cretaceous. So he said, well, CF Tenontosaurus. It's Camptosaur, almost no question.
From the Morrison,
Juvenile
Camptosaur.
Stuff. A lot of them. There are a lot of skeletons at that site. And we go further over, the Hoplitosaurus, Marshai, CF Hoplitosaurus, that they named on the other side of Arches. They tied it to Hoplitosaurus, which is good ID, because I think it's about the same age. It isn't. It's another new genus of elephant-sized Polacanthine.
Holy cow!
But at least it was somewhat named reasonably. But until we named Utahraptor, those were only 2 animals ID'd from these rocks. And half the colleges in the region didn't even accept the Cedar Mountain was valid. They put Morrison, and then on top of it, the Natarita directly on it, saying, well, this stuff, what's the difference? You got those sands, you map it, it's Natarita. Behind us, this is all Morrison. And superficially, that looks reasonable. But when we start getting dates, start looking at the animals, it's like, this is a huge record in between here, and almost every layer has a different menagerie of dinosaurs.
It's incredible.
It's it's going to continue to be a hotbed of work, and if anyone's listening that has deep pockets, help some of these small museums actually do something legitimate. Adopt it. Make it your own, and you can have a frontier at your footstep. I mean, we just got some pictures. A woman's owns some land north of Moab, and she's got some dinosaurs coming out on her property, private land. So there's very little private land out here. And Sue Sternberg, she's not going to let anyone dig it commercially. I'll guarantee it. But it's like, okay, who's going to work with her? And where is the material going? Because we don't have places to put it. It's really sad. The Field Museum, they've been doing a lot of work here, and Lindsay Zano, North Carolina Museum of Natural History. Lindsay, they found 2 nesting sites.
Holy cow!
Eggs as big as that. Pairs in these sites, and they're not complete nests, but they're nests.
Sure. And
she's got 2 of them that they collected, airlifted out of the uppermost Cedar Mountain, and are now being prepared in North Carolina. I mean, I would love to have a replica of those, cast those dang things. So we can put them on exhibit here in Utah.
Is that like Macrolongitudinalithus or something like that?
Yeah, Macrolongitudinalithus. which are giant oviraptor eggs.
Like Gigantoraptor from Mongolia.
Yeah,
maybe.
and basically Gigantoraptors are Koenig-Nathan oviraptor, which it's the only one known in Europe. The rest of them, Koenig-Nathans, are only North America.
Yeah.
And this thing is certainly a Koenig-Nathan. You know, so it's like, Gigantoraptor came from North America over to Asia. It was an invader, because they have true oviraptorids.
Sure.
And they don't get as big as these things.
Yeah.
You know, Angu and, Anzu, and these guys are big animals sometimes.
Yeah.
What is it? Neovenator. No, what is it? Neovenator?
No, that's a megalo.
No. What is the one from?
There's one from Utah.
The Cloverleaf one.
Microvenator.
Microvenator is a really old oviraptorid, and it's Koenig-Nathan.
Yeah.
It's like this. We had no connection to Asia until about 100 million years ago. Our connection before that was, we were basically isolated through the whole Ruby Ranch, the Aptian and Albion. We were pretty much an island continent like Australia, is today. And prior to that, this yellow cat interval, we have ties, and even the poison strip, we have ties to Europe clearly.
Sure.
And the Morrison, Portugal, they have Stegosaurus, Torvosaurus, Supersaurus, Allosaurus, different species, but they have like 5 or 6 of the Morrison genera for sure in Portugal. So you could cross, between Europe and North America, the end of the Jurassic.
And into Africa too, like Tendaguru's got a lot of the same critters.
Oh yeah, you could go down. Cephalodon, which we have from the yellow cat, it's a haramide. It shows us the root, the beginnings of its first haramide from North America. But the teeth are known in Spain now and North Africa, and it seems to be the ancestor of the Gondwanatheres of the Southern Hemisphere.
Gotcha. So it's a primitive mammal for anybody at home who's not.
And they used to think they were tied to multituberculates, but they're tied to haramaids. And the skull we found of Cephalodon shows that with some of the new big Gondwanathere skulls they got from Madagascar. Those discoveries just pulled this story together.
Very cool.
Yeah, it's pretty neat. But this lower stuff, we're seeing the opening of North Atlantic, and it's getting more island hopping to come back and forth.
You were talking about that with the Polacanthines.
Yeah. Probably on some. The way nodosaurs take over, at the base of the Aptian, North America, they're all nodosaurines, and in Europe, they're all Strethiosaurine nodosaurs, and they're clearly tied closer to each other than anything. But Europelta that I described some years ago in Spain, is a Strethiosaurine, and they go all the way to the end of the age of dinosaurs.
Maastrichtian,
with Strethiosaurus transylvanicus. And it's a discrete group in Europe of nodosaur, and North America, ours are all discrete to the end.
Yeah.
But they clearly had a tie together. So I figure I'm now really thinking that instead of ankylosaurs, these Polacanthines are tied to nodosaurs.
Really?
Based on pelvic structures. I could be wrong. It's a hypothesis, folks.
Sure,
That's how it works. But I figure on some of these islands as the Atlantic was opening, these nodosaurine types evolved. And whatever the big event, volcanic event that caused this global cooling episode, and Polacanthines went extinct, at least in Europe and North America. They might have survived in Asia for a while longer. Are replaced by these nodosaurines. These are like island hop to Europe, one group, made Strethiosaurines, another one on another island maybe, island hopped into North America. and from that point on, they never recombined. The Atlantic was just too hard to cross. But that's kind of the scenario I have.
It makes sense, yeah.
And it's, once again, more fossils, more discoveries.
Yep.
The folks in Portugal and in Spain, Spain and Portugal, that's the Gobi of Europe.
Yeah.
And when Franco was the dictator of Spain, the only dinosaur guy in Spain left for Argentina. And he wouldn't let anyone learn anything but Spain because Spanish culture was the top culture in the world. He just, I'm not going to fight it with Hitler. He thinks his thing, I think my thing. And so you wouldn't even let people learn any other language for decades in Spain. And certainly there was no paleo going on. And now that
This is
there's
Laura
really
Byrne
some
of Jurassic Park.
great paleo
Digging up
stuff going on
dinosaurs
in
is
Spain.
hard,
Incredible,
frustrating work.
incredible
Yeah,
stuff.
they're finding
Months
new
or
dinosaurs and
years,
new sites
so leave
every
it to the
day.
professionals.
And, I've been over there a few times, and I've been, gone around, and it's like, it looks like this. I mean, they have their own version of the pygmy forest, and of course, the spaghetti westerns could have been shot in New Mexico, northern Mexico, or Spain. Where they were shot.
Yeah. Which there's a dinosaur that's named after Clint Eastwood, right?
Is there?
Like Europasaurus Clint Eastwood? Europa Titan, maybe?
Oh, from Europe?
Yeah, from Spain. Yeah.
Yeah, it could be. I don't,
Spaghetti Western connection.
Yeah.
There,
But there's no question. You drive around out there and just, has anyone looked at all those outcrops? No. I mean, it's still an amazing frontier. Spain and Portugal. Yeah. Particularly Spain. Portugal, has been a little bit ahead of the game relative to Spain for a while.
More stuff from there so far.
But it's a smaller country, and Spain's got a vast area. But these guys, there's Triassic, there's early Jurassic. There's, it's not as continuous as here, but it's pretty continuous. Yeah. There's so much going to be discovered in Spain. And I'm real excited about it. And the stuff I specialize on, because eventually you got to draw the line. You can't do everything. There's more of this yellow cat poison strip interval, which then, my ties are more to Europe than they are to Asia. Which that starts in the mustn't touch it. Yep. And our work with, the late Cretaceous, that wasn't like, a connection there all the time. Clearly relative to sea level, there were different immigration events, and it might have been because sea level rose and went right up against the mountains from the west too. We don't know. Sure. But ankylosaurids with tail clubs don't seem to appear before maybe the mid-Campanian. Maybe the earliest. I mean, they just haven't got them. And there's no evidence. Well, there's the thing they call a nodosaur in Japan, but it's pretty scrappy, and I really don't believe it's a nodosaur. And some of the stuff they call nodosaur in China, I think might be polacanthine. Some late polacanthine animals that seem to have survived there, later.
After everybody else goes extinct,
and may give rise, to chamosaurs, but the whole ankylosaur thing, I think it ties to the new Portuguese ankylosaur that is being worked on, probably the most complete dinosaur ever found in Portugal. I won't say any more about it, but it's cute as can be. It's cute as a button.
Can't wait to see that get published.
It shows features that no one else shows.
That's awesome.
Pretty neat, But I'm hoping Russo can come over here and see our Jurassic stuff. It just, I think it would even look good on his resume. It's worth doing. He can do it without it. If he doesn't get enough money for this trip, he has a GoFundMe site trying to raise money. Gotcha. They come over here, and we're setting up going to Denver. There's people in Denver that'll house them and take them back and forth to the museum so we can do Gargoylesaurus. Nice, yeah. And Laurie McWinney, some of their material. And then you figure take the train to Grand Junction because it's pretty cheap to take the train and, worthwhile. It's a pretty beautiful train ride.
I want to do that someday,
really, before they close our trains.
Don't say that.
I know. But that, the Salt Lake to, Denver route is one of the best in the country. And then, work on Mymore Pelta and that material at Museum of Western Colorado. Sure. Then I thought I'd pick them up and loop them through here just so you can see the stuff and take them to Price. Yeah. Where I'll probably work with them a bit on some of those animals. And then, catch a ride to Salt Lake and study some of the stuff in our lab and at BYU. He, really would be catching the bulk of the early Cretaceous and Jurassic stuff in North America on that
an important part of the world.
Yeah. He also wants to stop at the American Museum. Nice. As he flies in and out of the country.
Some of that Anki stuff up there.
Yeah, Sauropelta.
Yeah, okay.
It's the best.
Stuff that Brown collected?
Yeah. With no records at all. I went through all his notebooks. All I could figure out is he needed to get new kerosene on those days. And he wrote one sentence, I think Osborne's going to be interested in this. And that's it. That's all he mentioned. Not
a different time.
Not even a sketch map. No evidence. They did have cameras then. Not a photo. No documentation of 3 nearly complete Sauropelta Edward eyes. just no data whatsoever.
Well, I mean, maybe talk a little bit about how we document our sites nowadays, and like what are best practices according to you?
Well, the process I've been using since I really started digging dinosaurs and being in charge. When you're a student, you're not in charge, so you don't have any say. But basically, you grid out your area. You try to size some of your grid points to quarter sections. The national surveyed points in the western U.S. And you lay down a grid. We've been doing meters, and we're scientists. From day one, we have grids so we can do things readily to the centimeter. Use plumb bobs to make sure we got it correctly. But we physically map stuff, drawing pictures on the maps where the bones are distributed. The hardest thing doing with these things has always been up and down, the z-axis. X and Y, pretty straightforward, but figuring out the relative height of things, because beds are dipping and doing things, it's real high. So, normally I'm a high, middle, low.
Yeah.
If I draw, if this bone's above this one, I draw it going across the bone, this one dotting under it. But that's sloppy, but it's very hard. I know BYU guys were doing stuff with a pipe with water in it and a little hose thing they take down.
Oh, really?
Yeah, to try to get the relative heights. Pretty slick little unit.
That's
They're using a
interesting.
dry
I've never
mesa.
seen that before. Yeah.
Yeah, this guy D Hall put it together. D was a great field preparator paleontologist from BYU and Vernal. He worked with my old boss Mike Perry in Vernal on a stegosaur. I think Mike was the first one to hire D doing paleo, and then BYU snatched him up. And, he was a nice young Mormon guy at the time. But D's a sweetheart, really good guy, and very smart, self-taught type of individual. But nowadays, I'm not against putting in grids, but we have this tool, photogrammetry.
Oh yeah.
And you can have your nail pins in there, and just taking overlapping pictures and create a 3D model, and do I still think we should do both. Draw the thing.
It's good to have
but
something.
Then also do photogrammetry to get the relative position of bones, because that gives you a good z-axis. Because if you're doing it right, you can measure to the sub-millimeter. And that's neat.
Very neat.
And I think photogrammetry supplants LiDAR, because LiDAR equipment is
expensive. Yeah.
You could do photogrammetry on a good cell phone nowadays.
Exactly.
That's
what I do.
I got 3D imagery software on my phone.
Nice.
So I can actually create a 3D image.
That's the future.
And it is. It's the future. We're going to be publishing 3D figures.
Yeah.
And of course,
some scientists already are. Yeah.
Yeah, getting permission. You fly a drone over this basin. I want to do it bad. I'd love to make a real detailed 3D model, of this basin, because when we look at the poison strip, you see it in those hills. There's almost no sand over there, and a big sandstone bench we're sitting on. Track it around, you realize there's another sand above it. It's people think it's like one sand. Much more complicated unit. And flying drones and creating 3D models with ground truth, walking on stuff too. Is going to open up whole new ways of understanding the floodplain architecture of these things. That you just can't do. Because when you're walking on this stuff, you're a little too close to your objects of study.
Definitely.
And
can't get that perspective.
Having this 3D model that you can zoom in and out of. On a computer. We made a model of the Dalton Wells quarry at Utah Raptor State Park. And it took like 3 hours to fly the drone over this ridge that the site is on. We did the entire ridge, maybe almost a square kilometer, maybe a little less. And in the 3D model, the smallest size, the pixel size, in the model, is about 1 square centimeter in reality.
That's incredible. How big is the area?
About a square kilometer.
Yeah, wow.
Yeah, wow. Prospect, other than a lot of times the bone pieces you're looking for a centimeter. These little flecks, so you can't quite prospect.
Not yet,
using it, but it's like
in the future.
Man, in the model, we're trying to figure out how to raise money, because it's going to cost us $10,000 to make it. We want to make about a 4x4 foot 3D model of it for the visitor center at Utah Raptor State Park, because then we can label it, and you can look up at the point and say, okay, this is the poison strip, this is yellow cat, this is brushy basin, just label these things and point out different features that they can see there. And, I want to put in eventually spotting scopes.
Yeah.
But you think as state paleontologist, I'd be, in the driver's seat on that whole thing. I'm not a member of state park, so, that they ask me anything is almost a miracle in my mind. It's just, we'll do what we do. But the folks doing the interpretation and the tiny space they have to do interpretation, talking to me all the time. We're working together, and we always have. I've helped them interpreting Escalante Petrified Forest, many other state parks. But when it comes to leadership, it's like we want to do it all in-house. Our group is the same way. We don't want to pay someone outside our group. It's like, well, we can have this person do it. Well, they really don't know it that well, the talent. But, keep the money in-house to help offset the cost of these programs for our citizens. We're a thrifty state.
That's a kind way to put it.
We're a thrifty state. And where I work is wonderful because we are at the Utah Geological Survey, all rowing pretty much in the same direction. And I've certainly been in university and museums where they're rowing in circles, just no one rowing in the same direction. It's just chaos of egos, and and we're all pretty committed that we serve the citizens of Utah, and we want because who doesn't want to know more about this land?
Exactly.
We're all totally in love with our state, in love with these landscapes. Realizing, we can do things in terms of geohazards, predicting landslides, dealing with water, these issues, we are, in our state, our legislature actually really does appreciate us, which is, kind of heartfelt for us to work here. They like us. That's so nice that they do realize we're doing good things. And other states like Colorado have tiny geologic surveys.
Really? In Colorado?
Tiny. Arizona the same way.
That's nuts.
Arizona, it's like a couple people tied to Arizona State University is the geologic survey.
Wow. And
what's amazing is there's big federal buckets of money for like mapping and stuff that they can't get because they don't have people doing this or trying to get. Colorado's gearing up a little bit. But for decades it was one person.
They had a state
geologist.
Too sunburnt.
The state geologist pretty much was the geologic survey.
That's crazy.
Yeah, New Mexico's got a big one. And they refer to it as the Bureau of Mines. But and the Bureau of Mines, they do the mapping. They do everything the Utah Geologic Survey does. But us, it's a little bit different. Oil, gas, and mining is actually a different division than we are, where it's part of the survey, down in New Mexico. Every state's different.
For anybody watching from overseas or from another country, I mean, in the U.S. is like almost like an accumulation of different countries in a way. Like different
a lot
state
of ways like
bureaucracies.
the European Union. Different states have very different ways of doing things, which is interesting. So you go, boy, I wish we did it like that state. But many states look at Utah and say, we wish we did it like Utah. Because we're the second largest funded group for state map. But we have people that know how to do this stuff. And now we're shifting the whole thing from mapping our terrains instead of flat maps from overview. We're now working the whole thing is three-dimensional maps. So our big goal now is we're going to try to create a statewide three-dimensional map of Utah.
Very like a state cross section, or
it's
like
a total 3D model that you can go into.
That's going to be awesome.
And look and have dotted lines connecting things in the air and going into the subsurface using well data.
Very cool.
Like going under the Uinta Basin.
Holy moly,
and that's what the state map, which is a federal project, is their goal is, we're shifting from just flat maps to three-dimensional mapping. In every state, and my previous boss, Grant Willis, who a fantastic geologist. I have a world of respect for Grant. Grant's like, well, as this comes on, I guess this is a good time to retire. He still works with mapping, but as program manager, and now we have Stefan, Kirby as our manager, and he's been real good. But he knows he's looking at a new frontier, and but he's young. That's why you got to have young people. I need to be replaced by a young person. This person is as old as me, looks good on paper. You got to get young, hungry, geologist to replace me.
There you go.
That'll grow into the new technologies, the new means of analyses. Because, when I went through school, they didn't teach cladistics.
Right.
Until I was like finishing my PhD.
In like the 80s?
Yeah.
Yeah.
And it's like, they're mentioning cladistics. What's that going on downstairs below my office? I've already done all my coursework, but that sounds like something I should know something about.
Yeah.
And really, I got through PhD in paleo. There's a train.
Oh yeah, I can see it.
That's Amtrak.
Really shiny one. Yeah, looks like a passenger train.
Amtrak's very shiny.
Yeah, very nice.
Yep. Yeah, people, you don't see anything normally, but there's a highway and a cross-country train track down there.
Nice.
People drive through that on the highway, and what a desolate, ugly place.
No, it's beautiful.
Well, the thing is,
it's a wonder.
They build the roads on the flat, boring stretches because it's easier to build a road. And you come down here, 20 miles south of us is Professor Valley. We have a canyon with multi-thousand-foot walls on it. The Colorado River at the bottom, just 20 miles south of us. You can't drive from here to those mountains. There's a big canyon that goes down all the way from Colorado and pops out at Moab, and then goes back into Canyonlands.
I did that drive last year, and that was incredible.
It's national park,
it's amazing.
Quality landscape. The San Rafael Swell. It's one of the most amazing places on the planet. It's almost became a national monument.
Yeah.
And it would not have hurt ananybody.
No, it would benefit.
What they need to do, though, when they make, something like that, they do got to designate routes for ATVers. Because there's a tendency, people say, let's ban this completely. And if people are going off the roads, off the trails, they need big fines. There needs to be consequences. Boom, you're $500, ticketed. So if a ranger caught me, boom, $500, fine.
But have designated trails for them to be able to use,
so that
we can all get
you're
along.
not throwing these people completely off the landscapes they're exploring. But just driving. Here's a hill that no tracks on. Let's drive up. See if we can go
let's
up
put
there.
some scars on this landscape.
Try taking the Spanish guys out did the Mesozoic conference. You're looking at some of the stuff.
I remember. I was there.
And they're just like, man, that wouldn't happen in Europe. It's like, it's
Thanks to
a little laissez-faire here. But you have to have space for these activities as well. It's like the Factory Butte area. Okay, this area we're protecting. This area, is an off-road, bomb it to death place. And you got to draw lines. Like, okay, this is off-road. The Moab area. The extreme sports. I mean, people riding bicycles, off the edges of Mesa and falling down on knife-edge trails. I mean, you've seen those videos.
Oh, yeah. That's
all the Moab area.
Oh, man.
And, that's pristine country, stuff in other countries. That'd be a national park. But it's like, okay, these are ATV, mountain bike, extreme sports areas. And you've got to set some of those aside for that.
Yeah.
It's like this is multi-use land, but certain places, this valley should be fenced off from oil exploration, and this is a major paleo site. Like Chaco Canyon is a major archaeologic site. This, we don't have another site like this anywhere that I know of.
Yeah, I mean, this should be protected. You were saying this could be worked for centuries.
Yeah, and it's totally unique. And we shouldn't just rip it apart because there's like new animals. We're going to find that giant, it's almost a T-Rex sized animal. Yeah. One of them got stuck in that marsh. We'll find one someday, but, it's a unique fauna. That may be the oldest Cretaceous fauna in all of North America.
Crazy. Right where we've been there. Yeah.
There's still more work to show that for sure, but I'm tending to think it is. Certainly it's the oldest multi-generic bone bed. Valkyria, it's always like, is the Valkyria stuff the oldest or not? But that's a real thin sequence. Valkyria.
So that's equivalent to like the lower yellow cat?
Yeah. There's there we don't have the calcrete, but there's a unit I call the cap rock that splits the upper yellow cat, which is pretty thin because we're getting to the edge of the basin there, Green River. All that stuff completely pinches out, but before you get to the swell.
Yeah. You showed us that.
But we do have both units. And we've discovered the lower yellow cat occurs, that facies, that type of strata, correlates between the burrow the Buckhorn River channel is this big Colorado River. You know, the early Cretaceous. Between the river channels, there is some floodplain that's very similar. But we don't have any skeletal sites and that stuff over there at all.
Sure.
So here, because this trough right in the middle of the Paradox Basin is subsiding, you know, we got, you know, some places 250 feet of yellow cat. It doesn't exist.
It's amazing.
You go over, get to like Hotel Mesa, you know, the Colorado River there pinches out as you head into Colorado. It's the swell, it pinches out completely. It's only in the at this point in the northern Paradox Basin. And because of that, you know, this is unique. And you know, as I said, Grand County doesn't just have the oldest, you know, Cretaceous dinosaur fauna in North America. It's got the 2 oldest. And these 2 faunas are never going to be found outside of Grand County, Utah. You know, people, you know, the first skeleton of Utah raptors in Carbon County at Price, the Prehistoric Museum. So they got billboards up in Carbon County, Utah raptor country. It's like, you're a little too far north. you know, you have to come down to Grand County. You know, and Emery County doesn't have Utah raptor either. You know, because we got nothing east of the river. You know, that's you know, those sites. You know, which is exciting. You know, it's neat stuff. You know.
So what first brought you out here to Utah years and years ago?
Well, my first...
Maybe hang on just a sec. There's a bunch of new people who came in, so let me do like a station break kind of thing. Welcome everybody to Paleontologizing if you just stumbled in recently. Talking with Dr. Jim Kirkland, Utah State paleontologist here, who's been digging up dinosaurs in the Colorado Plateau for...
nearly 50 years, probably 49 years.
Yeah,
you know, so
50 years next April?
Next April will be 50, it's the anniversary of digging up a dinosaur on the Colorado Plateau.
Incredible, yeah. How'd you first get out to Utah?
Well, for Utah, I was working in the Museum of Northern Arizona. And...
well, where'd you grow up in the first place?
I grew up south of Boston.
Okay.
And, you know, my dad came home when I was 1959, an old guy. Brought me a set of the Marx dinosaurs, the big 8. You know, Trachodon, you know, Brontosaurus,
the Tyrannosaurus,
little Allosaurus, it looks like a little short kangaroo, Triceratops, Stegosaurus, Ankylosaurus.
With the like ear things on it,
And basically, you know, the big 8, you know, which half of the animals were named wrong. There is no Trachodon. You know, it's either you say an Edatitan or an adult
Edmontosaurus.
Edmontosaurus. I like Anatosaurus for that group of things. And
it's a good name.
And Edmontosaurus regalis group. You know, I really do think they could be 2 different genera.
Oh, interesting.
But there's been overlumping. But Anatosaurus is for that, you know, later, more Horseshoe Canyon, Elk Creek stuff.
Oh,
you know, where the dinosaur parks up.
Edmontosaurus annectans, you think should be Anatosaurus?
Yeah, because that's what it was initially. You know, Anatosaurus annectans. And
Trachodon, I think, was initially Judith River, wasn't it? Isn't that
it's
one of
total,
Leidy's teeth?
Yeah, totally. You know, junk tax.
Yeah.
You know, you can't do anything with that. You can tell Lambeosaur from Hadrosaurine teeth, but that's about as good as it gets.
They're not that diagnostic.
Not that diagnostic. Teeth are not good for naming dinosaurs. They're great for mammals, though. And, you know, they get the advantage. You need a skeleton to identify a dinosaur, a good chunk of it. But anyway, I was at the Museum of Northern Arizona. I was working, you know, I got there actually to work with Edwin H. Colbert. You know, from the American Museum. He retired there. You know, the only guy writing good books for the public when I was young. You know, I mean, the leftovers of Roy Chapman Andrews were written much earlier. But Ned Colbert, you know, I named a dinosaur Ned Colbertia because he was my mentor. And I was next office to his for years. You know, he was retired and given housing at the museum there. But I was first called in to come up and as a student to help field check the geologic map for Capitol Reef. And we drove up and all over. Well, actually, I did a little bit of strat work, you know, in one of my classes, but we just got into Utah a little bit. But when I did the Capitol Reef project with George Billingsley and Bill Breed, you know, we spent a big hunk of time traveling around Capitol Reef and flying it because we had flash floods.
Oh, wow.
So we ended up having to spend a lot of our time field checking the map from the air.
So like in a little Piper
flew
Cub
all of
like that?
and flew everything. I mean, we were flying down canyons, so we look at volcanic sills in the canyon walls. And like, It was
That's
awesome.
amazing.
It was awesome.
Holy cow, yeah.
And George Billings, we're doing this with the guy that mapped Capitol Reef for the first time. And we've recently found big errors, but just people didn't know what we know now back then.
Yeah.
But that was my big first introduction.
Very
Then
cool.
I went over to the University of Colorado, and of course to get to my field area in northern Arizona, I'd be going through Utah, cut through Professor Valley, and cutting south all the time. That was the route. And I started coming into Utah, Jeff Eaton, other people showing me stuff that they were doing. So even though I was working quite a bit in western Colorado, it wasn't until I was teaching in Nebraska that the Museum of Western Colorado hired me to start running some dinosaur digs for them on the border. And then eventually, when my Gypsy Scholar term at the University of Nebraska was over, basically I came west and lived in Grand Junction. And one of my trips to Flagstaff to work on the Cretaceous, we're actually going to be working in southwestern Utah, Pine Valleys, stopped at the Moab Rock Shop and changed my life, because Utah Raptor got my job here. Yeah. But I'd worked, in Utah off and on for many years. It's hard not to if you're a geologist. Yeah. There's, big European groups. You go to Green River in the spring when it's not so hot. It could be 80 geologists from institutions all over the country in Europe, and oil companies, etc. Every major oil company teaches coastal geology along the Book Cliffs. It's the exact analog of all the drilling projects in the Atlantic Gulf Coast. The Farron Delta is the best exposed delta, and it's big as the Nile Delta. Exposed on the surface anywhere in the world.
So why would
oil guys come out here? Well, to teach them this is what you're not seeing by drilling holes into it. This is what these rocks, the relationship.
This is a cross section.
These are the kind of rocks that are given oil reservoirs on the Gulf. So in terms of the work they do in the Gulf, all the oil companies, train here. There's a British group that has core from in here stored at the airport, and they go downstairs in the museum, John Wesley Powell Museum, and teach courses on well logging and stuff to oil geology, smaller groups from all over the world. It's Utah is the training ground for many of the oil companies on this planet. In our sample library, core library, we have groups from Norway and coming over, because a lot of the North Sea oil, the salt wash, these crisscrossing channels, is really the model for what they're drilling to in the North Sea. So you get all these Norwegian geologists coming out to see the things, and Venezuela, all that oil, a lot of oil, is like the salt wash. This is where you come to see, what you're blindly drilling holes into and trying to figure out the three-dimensional geometry.
I didn't know that. That's so cool.
No, this is the training ground. I used to think when we were doing the Dynamation, dinosaur stuff, it's like we should do some courses on organic fuels, because you can see, oil fields, oil shale, all the oil shale in the Green River. Sure, yeah. There, coal beds in the Mesa Verde. You can look at coal. You go up into the Uinta Basin, gilsonite, which is they're mining dead oil up there, and you can come out here and do uranium. So for energy fuels, from Grand Junction, or you can do the same thing out of Green River. You can touch a group for an educational week-long. People who could do this for college credit. Energy fuels in a week. That you can do that anywhere else in the world.
Nowhere else on the planet do you get all that concentration.
In that kind of small area, every kind of organic fuel, and including the
and
nuclear
uranium
stuff.
Too,
And you can talk about wind. And you can talk about solar. It's like all of it can be tied into this area. Of eastern Utah. And it's it's one of those things that we don't really take advantage of in Utah. It's groups from other countries that come out here and run these courses, and rent the museum out for a few weeks.
Shoot, why is Utah not doing that?
No Utah-based groups do this stuff. It's all, oil company and consulting groups do all this kind of training out here. They stay in our hotels and stuff, but I want to turn Green River, White Sands into a field station.
Yeah.
Because we could be doing all of this
that
kind
would
of
be
stuff
awesome.
out of there.
Yeah. It's a great location for it.
Yeah, and there's like millions of dollar infrastructure that's just rotting.
Uh-huh.
And it's like eventually they'll just bulldoze it all down. It's like, if you gave me $100,000, I could set this up to house 100 people.
Build back better, yeah.
Oh, yeah. No, we can make common laundry area.
Yeah.
And a lot of the hotel owners, well, we want them staying in our hotels. They weren't using this as a base. These people are camped.
Yeah.
And if they're oil company types, they are going to stay in your hotels.
Oh, yeah.
They're not going to want to stay in bunkhouse settings. This is for students, the bunkhouses. But the rest of the facilities, would be, if it's oil company group coming in and using it, they're going to be staying in the hotels. They have the money.
Yeah. Boon for the local economy.
Groups don't.
Yeah.
And it'd just be a catalyst for research and innovation in this part of the world.
Yeah.
And it wouldn't be that expensive. You hire one or two, you hire somebody as like the janitor, maintenance guy.
Yeah.
I mean, really, it wouldn't be that many. And you link it to John Wesley Powell Museum. Say, we'll let you use this facility if you use some of our traveling exhibit area to outreach. What are you people doing?
Sure.
What are you learning?
Yeah.
And do the outreach to the community through the John Wesley Powell Museum, on Main Street, right next to the river.
Yeah.
The old director there, we talked about this kind of thing all the time. He's totally on board. But, it's like the University of Utah, they've taken over my wife's great-grandfather's homestead site on the Dolores.
Really?
And it's a field, they call it a field station. But it's like a square mile on this big oxbow in the Dolores. And it's pretty interesting. It used to be owned by, my wife's family. But the University of Utah owns it now, and they've tried to get me to base out of that. It's like,
it'd be a long trip.
It's too far. Yeah, it's too far. It's
not
an
a
hour.
central location.
It's over an hour from a gas station, over an hour from a store. You know? And that's why Green River as a field station makes more sense.
Yeah.
Because you can still be camped out here and working, but make that your hub.
Definitely.
And, if you break an axle, there's mechanics that can fix your car. And there's a grocery store. You can buy food.
Yeah.
There's laundry facility. You can do laundry.
There's taco trucks. We had wonderful burritos the other night. Holy cow, that was great.
It's, Green River could be a scientific hub with that museum for this whole region. You go, up north, you go into the Uinta Basin. You go east, you can go follow all the way to Colorado. Go south, you got Canyonlands, Arches, Colorado River through there. Southwest, got on the Capitol Reef. Go to the west through San Rafael Swell. In terms of country, that it's central to. Yeah. It's amazing. I mean, it could be one of the great field stations, like the American Museum's field station down in Chiricahuas.
Sure.
Of dinosaurs.
It's like, I want to see that happen.
If you aren't.
The University of Utah is like, I remember talking to their vice president for research there. And he's going, well, how pristine is it? I was saying, well, it's mostly asphalt. It's an old military base. But, for trailers, because, back then they were doing all out of trailers. There's over 100 hookups for trailers. There's basketball court areas and tennis court areas. They're all abandoned. You've got this huge building that's bigger than our core library. That could be, part of it could be turned into a multi-story set of bunkhouses. And the whole front half you could turn into a place with microscopes and computers. And, then you get the officers saying, you'd have to drywall everything.
Sure.
People would be
all decayed,
punch holes in it. It's all vandalism, but it's just the drywall. You just have to re-drywall everything.
Sure. Structure itself is good.
It's got, the infrastructure is solid. It's just, it's a great place to do it. And it's, is it pristine? No, but it's near, the University of Utah set, there at, they call it Entrada. They used to call it Entrada, they changed the name. But basically, it's a great place for retreats. They can house maybe 12 people there.
That's it?
That's it, yeah. The old homestead, whatnot. What was it, Pearl Baker, I think, when she was young, was just starting to write. She's a famous writer, related once again to my wife's. It's like her grandmother's second cousin. Pearl Baker wrote this thing about visiting the Scharfs.
Oh, really?
Which is, the other side of my wife's family lineage. The Oilers and those from Pearl Baker's group from Hanksville, and that group from kind of, Doling, down there at Sharp Mesa and this area. But they're visiting them, and they were trying to make soddies out of this dirt. So they're cutting, and she's describing it in this essay. Well, they're living kind of like in holes in the ground, like giant gopher holes, where they're piling up mud. This isn't like the prairies. You can't make soddies. And the guy, was a stonemason. They started slowly turning this stuff into stonework and whatnot. But when they were first in there, it was basically, it looked like a prairie dog colony that humans lived in. I was like, yes,
man,
family relations. And my wife's mother has the letters now from when after the Civil War checks. He was a Civil War veteran.
Yeah.
They're trying to give those checks like 20 years later, all the Civil War veterans. And he took the train out to Cisco, and then had to get a mule. And go by mule all the way down there, and I think they had a ford across the river. Because or maybe
no bridge.
There were fords, so maybe you had to take the mule across the river. Those fords have like 10-foot drop-offs now, but they were their way across the river down around Dewey Bridge in the old days. And this guy's writing back. He said that any human being would live this far away from every other human being on the planet is nuts. I mean, basically that's what this guy. To give him this check is like, and those guys are going to have to go all the way up. I think Cisco had a bank then. So because Cisco was the hub, for like oil shale, and it was a train station, that went out to here, and then of course the trains go north in Green River to Salt Lake. But because you couldn't go through the swell.
Yep.
Pretty serious barrier to navigation. This guy, that letter is just, it's like, man, why did they hate me so much to make me do this? Because the amount of travel to deliver this
to deliver a piece of paper, a check,
a check, or whatever, a certificate for our whatever his veterans benefits were. And to get in there, there's a trail that goes up over the Navajo and back down in Dolores, and it's a beautiful place because they eventually put in orchards and so it's a it's a beautiful place now. But when they first homesteaded that thing, I mean, basically they're almost having to climb cliffs to get over. They found a trail over the Navajo spur coming down there to get down into it. But you don't go along the river because there are cliffs on either side. It's to drive out of there and then go either all the way to Moab or Green River. It's almost the same. It's a little closer to Moab. It's stupid. It's stupid for a fuel station. It's like, man, every time you start running out of gas, you got to go all the way to Moab anyway. Green River, you can have a hub there with buildings where you can house a lot of people and store your equipment. And
do you think that'll happen? I mean,
I don't know. I've got a whole proposal I've circulated for almost 20 years now. And, the U is kind of interested, but since it wasn't pristine, it's like, you want to set up a field station in a national park. We're going to bulldoze a big area in Arches and make a field station. This is where you make a field station.
Yeah, it's already paved.
You do it. You got railroad. The airport there was for the military base.
Oh, okay.
So at airport, you can land big planes on it.
At Green River?
At Green River Airport, yeah.
Oh, wow.
It was
an Air Force base?
It was an Air Force base. It was White Sands Launch Facility.
Oh, there you go,
Yeah, they were launching rockets to where they crashed them
in New Mexico?
Yeah, they were crashing them into New Mexico, launching them here. This is the launch facility.
I didn't know that, wow.
Athena missiles and, a whole bunch.
Yeah.
The first cruise missiles were launched out of here.
Interesting.
Just hovering along all the way down to White Sands. Heck, I was doing field camp down with Socorro across the river, and they would have to say, you can't be out there Thursday because they're doing cruise missile tests. And the missiles are like 10 feet off the deck.
Yeah.
So it's like,
staying on the
radar. If you stand up on the street, it might take your head off. It might,
out there prospecting, the missile
out there sitting there mapping a ridge.
Oh man,
they were going right over our map area. But fortunately, they told people because
Yeah.
they were dropping them down where people were raising cattle and stuff. So
Oh man.
just think of the cows. Like,
Yeah.
oh, sorry, calves, no more milk, boy. That dried me up, but good. I was working on the res. We had B-52s flying low. There were times we were up in La Holly Point, and we're looking down on B-52s flying
Holy
close
cow.
to the deck.
Jeez.
And man, do they make a noise.
Oh, yeah.
So, but all those sheep just shedded all their fur. And they don't do that on the res, but the res was like, big jet planes. I was at Cold Canyon there once working. And we're up at the head of the canyon working in these brackish water sequences. And all of a sudden I look out and there's a pair of phantoms coming down below us, up the canyon. We're at the head of the canyon.
Yeah.
And I finally, Franz, you got to look at this.
Yeah.
And I just turn them around just as these phantoms
Two
came
F4
up
phantoms,
right over our heads.
Oh, man.
Just nuts. I mean, literally 15 feet above our heads, maybe.
Holy cow.
20 feet above our heads. I mean, the back exhaust blew us over. I mean, it's just like,
it's a powerful jet.
And those guys flying those things, would love. They see a herd of sheep.
Oh yeah.
That's, it's like nowadays you really can't do that. The tribes aren't real happy with
Up
you.
in Montana, we would find these big old 50 caliber slugs from P-47 Thunderbolts. During World War II, they used that as like a training ground. And apparently we heard stories from some of the ranchers. They used to go down and just strafe the cattle as target practice.
Oh yeah. No, these guys, no respect. I mean, they're like, man, that's not a good thing, guys. Not a good thing. It's like, I mean, no wonder the Navajo were like pretty leery of you outsiders.
It's understandable.
I was like, what the heck? You have no respect. But they don't do that anymore.
Yeah. Well, speaking of Cold War stuff, all the uranium mines that you were showing us out there.
Oh yeah, the Yellow Cat mining district south of us.
Yeah.
There were 5,000 to 6,000 people living there during the heyday mining.
Which is incredible because now it's nothing. There's nobody out there.
Yeah, but ghost town, in the 50s and 60s, was a trailer park. So you ghost town when when it closed, they all drove their homes away. All went gone. And you see, you got the dynamite sheds and old vehicles and old equipment. It's still there. A lot of it's been cleaned up. But the entire, I've always been amazed. But there were 5,000 or 6,000 people living there.
That's nuts.
All in trailers. And you can see the areas where they're heavy settlement and probably is that what the school? There's a school bus down there. They probably had a school bus that would bring people from the stuff on the other end of the poison strip over to the main Yellow Cat area.
Sure, yeah.
But those flats, you could easily park a bunch of stuff in there, tank in the water, and stuff. But there's a lot of uranium. We're closing mine features so people won't get hurt on them. Yeah, 190 mine shaft
around
openings.
what time was this that you were closing those mines?
That would have been in 2000.
Okay.
It was one of my first things I did was with oil and gas. Doing a lot of that. And since Don got hired, he got stuck with that.
Oh, really?
thing. But a lot of those salt wash mines, had dinosaur bones in the entrance. And what's happening, the uranium going down these sand channels, salt wash full of sand, in solution through these sand aquifers, all of a sudden they start hitting these bones and organic and logs, comes out of solution. And, that's the, ore bodies. As they hit dinosaur bones and petrified logs and things. Or little marshy plant sites, sitting right above the channels. The channel's abandoned and you get a little marsh. As the aquifer, water seeps up on a bend.
No expense.
Science
the fruit paleo area.
gifted Irish John Beans a
each one of those sites, you got uranium. Or vanadium's another one.
Vanadium
and uranium have similar
They have given 31
mineralization
gifts subs in the
histories.
channel.
The vanadium, you get this green staining in the rock. It's vanadium oxide, bright green. We're digging up a log at the Mygat Moore Quarry, that was just buried in with the bones. We uncovered this thing. It's jet black. And then virtually while we watched, it turned dark green. Just oxidizing the vanadium. No uranium in that stuff. I mean, you would think the bones are black. You could actually burn the bone.
Jeez.
But there's not, we put a Geiger counter up, you put it against the bone, it goes down from background. So it's like the bones are absolutely not radioactive. But,
That's good.
They're jet black. All the Morrison bone, pretty much fresh, or not all of it, but much of it is jet black. And a lot of times the black isn't carbon. I got more, it's probably carbon. A lot of this bone is uranite, uranium oxide, which is black. But then there are all these other uranium minerals that are yellow and blue and green.
Yeah.
Uranium minerals are real pretty.
You were talking about the smell, too, when you would encounter these old
and you
bits.
smelled that when we went through
Yeah.
Yeah, uranium mines, and not just these, the ones in the Triassic, the same way.
Can you explain that to everybody at home, like what that's... What
Yeah,
it
you
smells
go, when you're, in an entrance of a uranium mine, and I don't go down uranium mines because there's enough radon coming out already. But if you're near the entrance, we're doing these inspections, looking for, you're going to destroy. They didn't look at you for dinosaurs when they opened them.
Yeah.
Closing them, they look for stuff. But you get the sickly sweet smell. And it's, the organics, the stuff that causes uranium to come out of solution. But all the uranium mines, in the Jurassic and in the Triassic, have this sweet, sickly smell. And, in some ways I liken it to kind of like death. I mean, it's just, it's sweet, but it's sickly too.
Yeah.
But it's
something
a seriously distinct smell.
Yeah.
And, it's an active uranium, and there's more ore down there. And, of course, a lot of our uranium mines here were taken over by Mancos Resources. We're buying up all the leases. There's a Canadian company, I get the name of the main company up in Canada. And their mission statement was to take over all uranium mining and milling in North America. And a few years ago,
a little megalomaniacal.
Oh yeah, it's a Canadian company, but then the Russian company bought them up. And that's where, of course, Hillary Clinton got in a lot of trouble because the secretary, she okayed the sale, which is like, why would you okay the sale?
Oh yeah, I think I remember
of a company that owns almost all the uranium resources in the United States. And she probably figured, well, the Russians aren't going to be able to come in here and mine it. But the way paperwork went, they literally owned all the major uranium, resources in the Western U.S. It's like, Hillary, you sure you want to do this?
Probably not a good idea.
It sure didn't help you in the election, did it?
Yeah. Was it the whole Uranium One scandal? Was that the?
It's kind of like that because the Canadian company was, Mancos Resources. Their mailing address was Cisco, Utah.
Really?
Cisco, Utah is a ghost town.
Yeah.
Because I was looking at it like, these guys, are based in this area. Let me see if maybe I can try to talk them into donating some money toward our work. And, all you realize, their mailing address is a ghost town. This seems shady. And then you realize it's a subsidiary of a Canadian company that has a subsidiary based in the U.S. taking over all the uranium leases. I mean, it's, the U.S. is, like, you can't take over mineral leases in Canada.
No. Why are we letting that happen?
Of any kind. But you can come into the U.S. and just take over our mineral resources because laissez-faire, you give us money and we'll go with it. And that's how we operate here. Which I think is like, okay, do we really, because when this was happening, like, do we really want to do this? Do we really want to let the Canadians take over all our mines?
Sure, yeah.
I love Canada. They're very nice people, very polite, and hospitable. But
good dinosaurs too.
Yeah, I know. It's like, but you want them to take over all our resources, and they, I couldn't get a job in Canada doing paleo, but heck, half the people in Utah work in paleo. Scott Sampson, Mike Getty, they're all Canadians.
Yep. Yeah.
They came in here. It's like, but if they're not going to hire me at the Terrell Museum because I'm in America. We hire Canadians.
No, it's really interesting to think that because they were actually mining these dinosaur bones down there in the uranium mines.
Oh yeah, and the logs, and of course sandstones, porous stuff's full of uranium ore.
Really interesting to think that dinosaur fossils ended up as fuel for reactors on submarines and aircraft carriers and warheads.
Well,
and
pretty
stuff like
processed,
that.
$235.
Yeah.
They've gone through a little bit, so they didn't look like bones anymore.
No, I know that, but just
down
it passed through a dinosaur on its way to
Grants, New Mexico, all those mines there, it's the biggest area of uranium in the country. They reported this giant dino bone bed they discovered in one of the mines to the Smithsonian. The bones are like pure ore, and they're like, nah, we're not sending an expedition into your mine to collect radioactive dinosaurs.
Where would they store it? Yeah.
Yeah, so
be prepping these things in a full-on like radiation suit.
Yeah, but dinosaur, they collected a sauropod at Rainbow Park, and all of a sudden they realized as they were preparing it that the bones were radioactive, and they're like, you can't keep them in this building, so they put them in some cargo containers, out there, for years. It's like you open the doors of those cargo containers,
it's got to be. It can't be airtight. Yeah.
You need a venom, and set up some vented cabinets. It wouldn't be that big. It's not like they weren't at war.
Yeah.
Just enough uranium that they were producing a fair amount of radon gas. So you have a cabinet locked for a year or more, then you open it, you're going to get a face full of radon gas, and you got to vent those kind of things. It's the uranium history out here is kind of interesting. But there's still a lot of ore in the ground out here. But a lot of ore bodies are small. We're down working here on the edge of Bears Ears, Rainbow Canyon. We're doing mine closure surveys down in that part of the world. For a lot of the old abandoned mines, there's at least 3 or 4 active mines.
32 feet long and
family
14
uranium
feet
mines,
high.
the mom and pop
1,500
uranium miners.
And not a single cavity.
Those small operations. But, I found it like an ore body. I go around this little knob, and here, this is the basal Triassic stuff, the Shinrup, lateral equivalents. It's just black. Plant debris and black, it's like, that's uranite. That's an ore body. But the way the point is, you come in here, some dynamite, pickup truck, or maybe a small dump truck. You'd mine that thing out in a couple weeks, but it's seriously good ore, and that's kind of how a lot of the ore is down there. These small pockets of really concentrated ore. So you come out and you clean them out, and it's done. You've mined out all the ore, but I found an untouched ore body there right on the surface. Oh, that's interesting. And the mineralization, around so there's blue, there's copper tied into a green, yellow. I mean, all the different various, oxides of uranium and copper and vanadium. I remember just taking pictures of all these different, sandstones colored different, these bright colors.
Sure.
It's just, man, this is seriously mineralized right here. I think, and it was not that far from one of our campsites that we had used in the past. It's one of the only places you can camp there. It's real rugged country. It's just like, man, look at this stuff. This is if I told the guys up there they'd put a claim on it, just bump that knob would be gone, and the mine would be over, because it's certainly economic. Maybe 10 feet overburden.
We just got a bunch of new people who joined us. So hello everybody, thank you. Who was that for the raid? Zachub, how you doing? How was your stream? Welcome to Paleontologizing. I'm Danny Anduza. I'm sitting here with Dr. Jim Kirkland, the state paleontologist of Utah. And he's dug, would you say you've dug more dinosaurs in the state of Utah than anybody else?
I don't know, Getty, the short time he worked here, he was voracious.
Yeah. You've named more dinosaurs.
I've named more dinosaurs than most anybody alive today.
Yeah.
In the U.S. Or co-named.
Not to brag or anything, we're just stating facts.
No, not and not always the senior author. Like when we did Mirasaurus from down below there.
Yeah.
I brought in a sauropod expert.
Sure. Who was that for that one?
Rafael Rojo Torres from Spain.
Oh, okay, yeah, you mentioned that.
And, he named Torreosaurus itself and several other taxa, and he's been able to convince me that is a Torreosaur.
A Torreosaur, yeah.
Previously only known from Europe, as is Moabosaurus in the next level up. Though many U.S. sauropod guys don't believe it.
I think it's descended from Mirasaurus.
You guys fight it out. Species is valid. Bob Younghigh, named after the first guy to work on the Cedar Mountain and do good stuff. He did remarkable work. He got trashed by the USGS and some professional 5 rebuttals to his paper. And even when I did my PhD, I acknowledged this piece of work. Dakota group in the Colorado Plateau. He included this in the Dakota group. But I just said, Bob Young did this thing, had 100 strat sections, but his work's been largely ignored, and that was it for my pieces. That's all I said. And I started working out here, I realized Bob Young was right, and all of these other people were flat out wrong. And I told Bob that. I named, Mirasaurus Bob Younghigh, I'm naming a dinosaur. and he passed before it finally got named, but he knew.
He knew it was coming?
I was naming a sauropod after him.
That's the measure of immortality right there.
Because he earned it. I mean, he really did largely figure it out. He didn't have the lower yellow cat, but if you look at his cross sections, you can make out the upper yellow cat and the because he used the base for the calcrete. Because Cedar Mountain's loaded with carbonate. Yeah, and he just didn't realize there was this lower interval still Cretaceous under it. Looks, it's got dark red beds. It looks just like Morrison.
We've got somebody in chat says Amberlin says Utah, home of the Utah Raptor? ? You're talking to Mr. Utah Raptor right here. Yeah, the man himself. Yeah, that was what 93.
We discovered the first one, the one we named.
Yeah,
it's about 6 miles, or actually about 4 miles due west of us here at the Gaston Quarry. Is where the first one was found. Here we find the ancestor Yorgovuchia. Yeah. And Yorgovuchia is still a giant raptor, but we named it for the Ute word for coyote. Sounds Slavic, but nope, Yorgovuchia. Nolinga is named for a Ute word for coyote. It's, medium-sized, small predator.
There you go, yeah. Medium-sized for the time.
Yeah, it was actually, we got an ilium this big, we got a complete pelvis.
That's huge.
It needs to be described. Because the first one was a juvenile, obviously.
Oh, okay.
And then we found a pelvis of one, not quite as big as Utah Raptor.
Yeah.
Utah Raptor's still about twice as big as the biggest Yorgovuchia, but Yorgovuchia is bigger than Deinonychus, so it is one of the biggest of that line.
So with Utah Raptor back in the 90s, what's like the time frame there for when... Because Jurassic Park was being...
when Crichton published the book, was the year we discovered Utah Raptor in the ground.
Okay, that's 1990?
1990. Yeah. And that's when the book came out. And then, we're working on it, and the site, and I brought a cast of it in, 91 to the SVP meeting in San Diego. No, I brought it out to Dynamation. San Diego's first was probably fall of 90, when I first showed it to John Ostrom. But then I went to the Dinosaur Club meeting in Burbank. A lot of movie people and stuff were there. Yeah. Pull out a cast claw, I found this giant dromaeosaur. That's cool. Show and tell kind of thing.
Do you think that's where they got the idea for having the claw in the movie as a prop?
No, this is what happened. Okay. I'm passing around the room. You got a number of actors and stuff like dinos. Yeah. And this guy sitting in the room, I didn't know who this guy was. And he reaches in his pocket and pulls out this brown thing that I still own because he gave it to me. And says, "This is the claw of Spielberg's raptor." And this is when I discovered he made it twice as big because it was based on Deinonychus, even though it was called Velociraptor.
In the novel, they call it Deinonychus anteropus, I think, which is...
No, they call it
Velociraptor anteropus.
Anteropus, yeah.
Sorry.
Which is Deinonychus anteropus. Yeah. But he passes, has his claw, it passes it over to me. I'm looking at it. I don't think he said anything about the movie at that point. Passes it over to me. And I'm looking at him going, this isn't real. You can see a drill, where they put the pipe in, when they're making it on the animal. Look at this thing, and it's textured like a ram's horn, and the shape isn't even a smooth curve. It kind of goes and down. It's a weird, shape. It's not a mathematical curve, which is most life does mathematical curves. So I'm like, this isn't real. That's Spielberg's raptor, and you hold it up to the bone claw. The cast we had of the thing we excavated. They're almost the same size. But if you put the sheath on ours, it's considerably bigger than theirs. But it's on the same size animal, pretty much. Yeah. I mean, the hip height on Utah Raptor is only like that high. Yeah.
A long tail on it.
Because they have relatively, dromaeosaurs have relatively short legs. And the thing was massive. It was built to kick the side out of a barn. And I think just, punch holes in a sauropod and march up like
clamber
a nice
up
climber.
the top.
Just boom, boom. And, I always liking people, used to think it's slack could cut, but, I always
it's not the right shape for it. It's not like thin.
Well, it comes to an edge. The bottom side's an edge.
Really? The ventral side is
that? Oh, absolutely. Huh. Yeah, and the top is rounded, it's about that big across, rounded, but it comes to an edge.
Interesting.
On the downside, there's no question.
Yeah.
But, okay, no problem.
What's that?
They are in my pocket.
Here, let me run them over. Yeah.
So, folks, as we have this little intermission.
Yeah. Yeah, no worries.
It's actually not bad out here today.
Yeah.
Most days,
cool.
the 104, we're dying by now.
Yeah.
We're in the sun.
Somebody do the weather command and see what's our current temperature right now for Thompson Springs.
It's surprisingly decent.
Yeah.
I'll tell you another.
But it'll get hotter.
Yeah.
And I don't see many clouds to protect us later.
Oh, and before I forget, too, I should say, if anybody would like to help support our work here and help buy us supplies and food and, extravagances like, I don't know, bread and water.
Feed the students.
Exactly, yeah. Don DeBlue has a Venmo account, and there should be a command for that. There you go. Thank you, Claire, for pulling it up. Don DeBlue 2112. All that money goes directly to us, so if you'd like to make a direct contribution, that's how you do it.
That money goes to feed the students. It doesn't come to me or Don.
Exactly.
We're using it to support students that intern with us out here. Because we can't pay them, but we can feed them, we figure.
Yeah. Better than nothing. Yeah. And we really appreciate all the support we get through that. We've had some very generous support so far. So thank you. That's keeping us fed and hydrated out here. So yeah.
No, definitely. Very appreciated.
Yeah.
It's pretty much we're paying out of our pockets for these kids.
Yep.
They are priceless. But the only reason we're out here when it's 104, 100 every day, is the academic calendar.
Exactly.
It's so important.
It's been your soapbox for the past 2 weeks.
It's like, why can't they have school end in August and have vacation like the end of August into November?
Yeah.
When it's nice to work out here. Like, with global warming, I really do think we should shift it.
It's going to make sense, yeah.
It's completely unbearable in July. Dude,
yeah.
It is so hot out here anymore.
Well, let's talk a little bit about what we do to try
and finish the...
oh, yeah, go for that,
the Spielberg thing.
Yeah.
They passed me this claw, and it's actually bigger, and it's very blade-like. But, think if you want to kill an elephant, and you had 2 resin Bowie knives. Not steel, but plastic. Because keratin, kind of like a hard plastic.
Yeah.
So, okay, I'm going to run and I'm going to jump on an elephant with my plastic Bowie knives and try to kill it. I think I would lose.
I
think this thing would grab me and just beat me to a pulp. So, I don't think they were... Because you couldn't slash through, you couldn't cut through inch-thick hide, a big dinosaur of inch-thick hide, with plastic keratin, I think maybe they're pseudo-serrated by growth lines.
Okay, yeah.
Maybe. We don't know this at all, because it's not preserved.
Yeah.
But, so you could get a little bit of sawing action. But if you look at the curve of that claw, if you were going to kick, you could punch holes because these leg bones are 50% bigger than the same size leg bone on an Allosaurus.
That's nuts. Yeah.
I always think of this thing as built like Arnold Schwarzenegger. This thing has got huge muscle attachments, very strong. It's not fast. The young are fast. These things change a lot as they grow.
Yeah. And
it punch holes in the animal, and it probably still could kick like a cat. And if any of you have picked up a cat that didn't want to be picked up, you can't even see how fast those legs go. But it'd be punching holes. I don't think it would be slashing. But those holes, could use them to help support it. And these recurved claws on its hands for grip. To just climb up the side of a bigger animal.
Get up to the neck.
Get up to the neck and rip the throat out of the thing using its mouth. Which is certainly not reduced in scale relative to any meat eater at that size. The teeth are this long in a Utah raptor. Very effective, for ripping the neck out of something. And that's kind of how I figure out that when the young are running around, and these guys
they're
are like, what's going
predators,
on? Yeah, they're young and fat, small and fast. And like Allosaurus does the same thing. Allosaurus speedy guy, T-Rex babies are like climates.
Yeah,
it gets about half grown and all of a sudden they bulk up. And Utah raptor seems to show that same pattern. The young, if we're right, future scientists, you young scientists out there, you're going to tell us what happens to Utah raptor when the fossils we've been digging up get prepared.
Yeah.
But it's doable. We can understand this eventually.
Yeah.
Which is what I love about our science. It's like
the answers are out there. Like someday we're going to solve this. Yeah.
It's crazy. We 20 years, 50 years ago, we clearly didn't think we would solve this. We have Upper Triassic, Upper Jurassic, a couple levels in the upper Cretaceous, maybe this little bit of early Cretaceous of Montana. That was it. That was the entire dinosaur record. Utah right now, well, if you count the Joe Surdich faunas, we have 33 sequential dinosaur faunas that are non-overlapping. 33.
That's
when I was a kid, it was like 5 total.
That's nuts.
And it was 5 until I was into college. And now in Utah, we know in sequence in this pile of rocks from the Triassic up, 33.
That's incredible.
Faunal levels.
I mean, nowhere else on Earth can match that.
Now, China has great stuff. But they don't have this sequence, and all their basins. You can't even correlate across a mountain range because it's so complicated over there. China's a great record. I don't deny it, and they're working hard to create a chronology.
Oh, yeah, they're doing amazing work.
Building the chronology in the U.S. is way simpler than what they have. And this has been one of the hardest stories because the Cedar Mountain here and the Cedar Mountain on the other side of the Severnfell Swell correlate like that.
Real mean kid.
Going the very base
With
of that stuff
for
and the very top of our stuff
of his neighborhood.
correlates. Otherwise, they're two completely different sequences of rock. It's interesting. 45 million years of dinosaur history.
And there's much more to be found, too.
500 feet of rock.
Yeah. I mean, you were talking about how if there's ever a North American Spinosaur that gets found.
It'd be, I think, Natarita.
In the Natarita Formation here in
those
Utah.
rocks that are capping, see way over there behind us, the more brown, orange-colored sandstone, and the stuff above it, which has coal beds in it.
Yeah.
That's the coastal Cretaceous. And, in Cenomanian, Spinosaurs survived till the end of the Cenomanian, then there's a mass extinction, and they go with that mass extinction that killed off many of the fish they probably ate. But if we're going to find them, that should be where it is, because the Gulf Coast, those coastal rocks that extended over toward Europe and those areas, there's no outcrops of them. It's just not there. But someday it may be we got a North American.
That would be the place
dinosaur.
to look. Yeah. Very cool.
And I've looked a little bit for it, but it's a stingy unit.
Yeah.
But it does have stuff here and there.
Really cool. Is there any predictions for future dinosaurs that might be found in Utah? Gaps that exist in lineages or something like that? Putting you on the spot here,
the middle Jurassic.
Yeah.
We have very little. The only good middle Jurassic in North America is in Mexico. Tumulipus beds near Monterey. And they've produced pterosaurs and a couple, mostly other small animals. The youngest occurring tritylodons are probably in that bed. They're probably middle Jurassic in age. Worked with my buddy Rene Hernandez of University of Mexico and Jim Clark. At George Washington University. But Jim and Rene are good buddies, and of course all my work in Mexico has been with Rene. My good buddy, and of course Jim Clark helped establish the Fruta Paleo area, which certainly sharpened my chops in figuring out things in the terrestrial realm. So it's all this crossover, between. It's a small profession.
It really is. Yeah.
I mean, it really is.
Yeah.
A lot of interplay between people. Ethan's going to come up here and say, "Well, I just trashed the truck. Sorry."
I hope he's fine. Yeah.
Yeah, I know. I get a little nervous.
Yeah.
Remember the fan belt? I mean the
serpentine belt.
Came off.
So
after he borrowed
the Suburban wasn't working the other day, and so I go over to take a look at it, and it's like, where's the belt coming off the alternator?
Bring it around.
Me and Ethan and Bilal were able to reseat the belt and get it hooked onto there. And oops, the camera's almost getting blown
Oh, he
over.
went the wrong way. What are you doing? I thought he went on the other side, this side of the loop.
He's backing up, that's fine. Yeah.
Our intern. But Ethan is going to be a player.
Absolutely, Remember that name, Ethan Cowgill. Holy
Ethan
cow.
Cowgirl. And look at his site on YouTube.
Yeah, what's it called?
The Living Past.
Yeah, check it out. He's got a good video about Doling's Bowl right here. So if you want a good intro to that.
It's well done. A little bit of David Attenborough-esque, but...
but that was when he was like...
He was
a wee boy when he
junior
made
in high
that.
school when he did that.
Really?
Really good, yeah.
Wow. Yeah.
Well, some of his others he was doing at 16, and
yeah.
He's got like 20 or 25 of these videos, and they're excellent. They really are.
Yeah.
this is a guy that's got some real.
He's gonna do some amazing things in dinosaur paleontology in future years. Yeah, and he's doing some amazing things right now. We might even get a chance to interview him. Who knows? Because Jim, you're taking off tomorrow or something?
Yeah, for a couple days.
Yeah, okay. So you'll be coming back.
Yeah.
Nice.
Being an old man, I got to restock my medicine cabinet.
We all gotta do. Yeah, we all need a break.
Well, I was gonna go for the weekend, but
Camera's getting blown around by the wind. Change direction. Let's see if I can reseat this. And let me know, everybody in the chat, if hopefully Jim's face is not still blurred by that scratch on the lens.
Now you're pointing this way, so.
Yeah.
Showing bowl is a bowl.
Yeah.
Keeps telling me I'm
Very
south.
bold.
All these
So I
rocks are
guess this
dipping to
might
the north. We're on the south side of the Uinta Basin. And the center of the Uinta Basin is probably 70 miles north of us. It's a big basin.
Huh.
Basically as large as many states. But the center is up, middle to almost upper Eocene. And one of the great mammal records of the early part of the Tertiary North America are in that basin. We always think dinosaurs here, but the first 20 million years of the age of mammals is quite well recorded here.
Nice. I mean, yeah, up at the Vernal Fieldhouse Museum. The smudge is over your face again. I gotta move this. Hopefully that's better. Beautiful displays up there of all these Eocene mammals and big old taniodonts and those weird critters. Uintathirs and stuff.
And if you go to the North Horn, we have pork and basal Paleocene mammals.
Really?
I used to
nice.
look up float stuff.
Do you have the boundary there too, or is it just above?
Yeah, the KT boundary's there.
Nice.
It's mainly, I don't know if we have an iridium layer there, but as you're going up, the highest fossils that are Cretaceous are dinosaur tracks. You can see tracks and then they stop before we get to the Paleocene mammals. And you get dinosaur eggshell. There's lots of dinosaur eggshell in the North Horn. It's loaded. But eggshell goes all the way up to the boundary.
Yeah.
But because of the nature of those beds, they haven't found an iridium layer there.
Interesting.
People have claimed, I think Brooks Brick claimed they got shock quartz up there. But it's like, the context. But it's certainly, there's a Cretaceous Paleogene contact up there. It's just, where it is, and it's not in a coal seam like we got north.
Here, let me see if I can scoot the camera around a little bit, because people are saying the angle is no good now with the sun moving.
Pointing straight into the basin.
Yeah.
I put it there, pointing more this way.
Just like that. Let's see if that is any better. Hopefully we don't lose signal.
See our good section back there.
Yeah. There we go. And then that should be about the right angle there. Got to switch out the cameras because it's got a scratch on the lens now. Luckily, these things aren't very expensive.
The kind of GoPro.
It's that's a Sony Action Cam, which is like the generic GoPro.
Oh yeah.
Just like 1/10 the price.
Yeah.
Yeah. This is an old one. They don't make it anymore, but you can pick them up on eBay for like $30.
Oh wow.
So yeah. But yeah. Anyway.
One thing you might want to note.
Yeah.
Where we're sitting here, I don't know if you can see the.
Let me move the camera. We'll take a look. Yeah.
Yeah.
This is cool
stuff. We're on the Poison Strip Sandstone, but if you look at where we are, and you can pan over there and over here, see this real light-colored rock? That's an orthoquartzite.
Orthoquartzite.
And because it's made by sedimentary process with cement and not metamorphic. But it's so dense, I've had people argue with me like flat out, what's the metamorphic source there? Because it breaks through the grains, which is usually how you tell an orthoquartzite from metaquartzite. Metaquartzite
is metamorphic, yeah.
Orthoquartzite, when you break it, they go around those sand grains. But this stuff is so well cemented, it breaks through the grains. This is a not Paleo-Indian, but maybe Fremont age or older Indian quartzite quarry.
Very cool.
And they use these to make axe heads, hammer stones. Very tough material, but it takes a sharp edge. And everywhere you go in the Poison Strip, you get a lot of normal sandstone.
Sure.
But then you get these zones that were cleaner sands that are cemented very, very hard. You can look where they're hammering here. This conchoidal fractures.
Yeah, look at those.
Of this stuff. And we found, hammerstones and actually the mining tools the Native Americans used on these sites, but this whole valley is wrapped with these things. And the same correlative rocks over in Colorado also show major quarry sites of quartzite. This is a real important resource.
So people would be coming to here from miles and miles around just to be able to get this.
And our silicified chert beds, and I'm not sure you've told your followers about the silicified peat down below the site.
No. Yeah, haven't really had a chance to yet.
But they're mining that stuff for arrowheads.
Really?
You know, it's more brittle, but yeah, there's definitely quite a few sites where it's clear there's a lot of chips of where they're getting nice choice pieces and making core stones and taking flakes off them for arrowheads and other tools.
Sure.
So you've got two major resources that occur around this basin.
Pretty special place.
So they're mining this area, but they don't have pinyon pines, because they eat pinyon pine nuts. Pine nuts are great. They would use the bark of the junipers here and rough it up and actually use it as an insulation and put it in their babies for diapers.
Really?
Yeah, because it would absorb whatever. It was easy to get access to it. It makes sandals out of there, juniper sandals. They'd use the berries and boil the berries to make a resin that they could waterproof baskets with.
Oh, cool.
Just the resources here. There used to be this yellow flower like a daisy. I don't see any here. I think climate change.
It's too dry for it now?
Yeah, because it's usually all over. And I had some Navajos. I spent much of my early life working on the Navajo reservation. And a Navajo woman once gave me this is the resources we use out here. And there's this one daisy-like flower that they boil to make a soup, healing soup with it, teas with it, and it's got yellow flower. It looks like a daisy. Whereas out here, they utilize that. I mean, it's amazing the resources, but there's so many of the plants. Ephedra, of course. Is boiled down for.
That's Mormon tea or something, right?
Yeah, Mormon tea is another name for it.
Okay, yeah.
There's probably 6 or 7 species of ephedra, out in this area, and of course, ephedra is in not a conifer, a gymnosperm family called the Nitales, and it's unique. There's only 3 living ones. There's Nitum in Europe. Welwitschia, which is this weird plant with these 2 big strap-like leaves. South Africa.
Out in the sand
dunes
and stuff?
for hundreds of years, and the leaves just keep shredding off.
Really weird.
And ephedra. There's only 3 genera of that plant. A much more important plant back in the Jurassic.
Yeah.
But these you can consider it kind of a living fossil. There's a real nice one there at your feet.
Yeah, I was looking at that earlier. Yeah.
The green stem, they put out little cones. Not a flowering plant. But when you look at this landscape, there are a lot more resources, but we're losing them. There are none of those plants, and usually you see them coming out. Their leaves, even when the flower's gone.
Sure.
I think I've seen one out here. And there used to be lots of them. In the spring, there'd be nice yellow flowers. Also, areas where we're working, which is pretty wet, in the spring can smell like onion because of the sago lilies. All the bulbs come up and blooming. Our state flower is the sago lily. Oh, interesting. And they like the wetter, flat lowland areas. But when they're in bloom, you'll be in an area and it's like, man, this smells like garlic, onion, or whatever. And they utilize those bulbs and use that in their cooking and whatnot, just like you use onions. Yeah. So it really is. Man, you look at this landscape, it's like, how are native people living off this stuff?
I mean, yeah.
And it is worse now than it was then.
Oh, yeah. You're in a spot for a long time. I mean, you learn everything about it.
Yeah, like these flats here, which are, sand dunes and cheatgrass. Back in the 20s, grass as high as a horse's belly. And then a continent-wide Dust Bowl drought. They just kept grazing levels up. No one knew better.
Yep. And just like tilling all this land, too. There was, I think it was some government agency. They'd told everybody to go plow the land.
Oh yeah, well, the
rain follows the plow.
The plains, yeah. And they used to, there's a comment. It's in Centennial, which really talks about this. But the plow marks, you should be able to follow them from the Mississippi River all the way to the Rocky Mountains. The individual grooves. And of course, setting up those grooves,
wrecking everything.
Yeah, when the wind came up.
Yep.
Death storms.
Yep.
When it dried out in the drought. The better meat is make it hackly so you don't get that wind blowing along the surface, picking up every bit of topsoil you got. It was just tragedy. We didn't know better.
Yeah.
I thought I saw a reflection by our road a second ago.
Like a vehicle or something?
Yeah, I'm wondering.
There's some shimmering over there.
Yeah, is that a vehicle? But we're not moving. I thought I saw. You can see the road coming into the basin there. Yeah. Going across the Natarita.
Now, you were talking about the Marx dinosaurs, and then we kind of shifted. Like, was that one of your first exposures to dinosaurs as a kid?
Yeah, and very early on, I was a precocious little dinosaur, nut kid. Yeah. Neighbors, I'd be walking down the street, they'd be having a barbecue in their house, and, hey, that's Jamie Kirkland. Ask him about dinosaurs. So I became the local entertainment for,
I can relate. That was me when I was a kid.
First grade. I was insufferable, but it's unlike many 5-year-olds that want to be paleontologists.
Yeah.
I actually pulled it off. And that might be a defect of personality. It's like, man, you couldn't figure out something more lucrative.
Exactly. Yeah.
I know a lot of people who are into paleo young that became doctors. I don't know how many doctors I've met over the years. Yeah, I came to my senses in college and switched into pure biology and went to medical school.
I mean, that's why what we do is important. Like, I don't know, we're not necessarily out here trying to cure cancer or anything like that. But,
absolutely.
But we're inspiring people to get into science, and that's
it's a gateway science. There's so many kids that start going to libraries and looking things up.
Yeah.
And going, nowadays going to the internet and looking things up.
They learn to, they fall in love with learning through dinosaurs.
Yeah, bigger in their backyard. This giant vista of deep time. It's it's really remarkable how many people have had an interest in dinosaurs that are in the sciences or medicine at one point or not in their life.
Definitely.
I mean,
I'd love to see a study done on that with just like a representative sample of scientists and how many of them first got interested in science because of dinosaurs. Slash
is the dinosaur guy.
Oh, yeah?
Oh, yeah. I mean, there's so many Hollywood people that are, dinosaur guys. What was the guy, the Night Court, the big county, he's like Lurch, and you remember Night Court?
Yeah, what's his name? I've never seen Night Court, but they had a Night Court episode of 30 Rock, Tina Fey's show. Yeah. And they had all the characters on that. Yeah.
Well, they're the real characters. But anyway, he used to come to all his dinosaur club meetings.
Oh, really?
There's a bunch of them.
There was an SVP video that I stumbled across on YouTube with Sam Waterston from...
Well, he's in, what is SVP? We are SVP. He's just a narrator. He did it for free because he likes dinosaurs.
That's awesome. Yeah.
He likes paleo, but it was a propaganda video made by SVP. We are SVP. What the heck is this group? And it's online on the SVP site.
I tried to find it the other day and I couldn't.
You should be able to just go to the SVP website. You don't have to be a member to get to that.
Yeah. No, I was searching for it on YouTube and it wouldn't come up.
Yeah. I think it's through the SVP site.
Okay.
So you go to
it
SVP site and it's like, SV, what is it?
Yeah.
I can't think of the name.
I was looking for that the other day because we had a tradition with the Museum of the Rockies cruise where every summer we would we'd try and figure out if we were to make a movie about this field season, which actors would play each of the crew members. So we were trying to figure that out last week.
Yeah.
And I said Sam Waterston would make a good Don DeBlue, and So I was trying to look up his video so I could show people.
They give me John Goodman.
John Goodman,
a couple years ago.
I don't know. He's a distinguished guy. I think he'd be an excellent Jim Kirkland.
Oh yeah. No, he's slim and trim now.
Yeah.
Yeah. He's really done some good things. I have to admit, I'm jealous.
Yeah.
No, we used to talk about the Mars Cope feud, because I'm pushing real hard to try to get a Mars Cope Dino feud movie.
They were working on it for a while.
Yeah, no.
Before James Gandolfini died.
Yeah, and we were like, who was it? Yeah, he was going to be Mars, right? And when we were pushing it, it was like, oh man, who were we head for Mars? It was another guy I think that was in.
I could totally see.
Not Night Court, but I'm blanking on his name.
Yeah.
He's still alive, I believe, but we had the Martian. Who's going to be Mars? Who's going to be Cope? But that should be done sometime.
Yeah, absolutely.
Because it is so good.
Yeah.
You know, I remember reading an article, American Heritage. They did a quote from Marsh, you know, chapters written by O.C. Marsh about when he was out with Jim Cody, you know, came to visit camp.
Oh,
you know, he knew everybody, you know.
Yeah. Wait,
And
Buffalo Bill Cody?
Bill Cody.
Yeah.
And the two of them ended up in a buffalo stampede. You know, and they reprinted that little article in American History magazine, which was pretty neat. They didn't do much with dinosaurs in that magazine, but that was a certain historical piece. I think it was written by Marsh, but Cody was in it pretty heavily. So the two of them.
There's so many different anecdotes and everything.
Well, Red Chief, you know, considered
Red Cloud,
Red Cloud,
considered
Marsh the only honest white man he ever met. You know, and he did a lot to
it brings up
try
Marsh
to bring up
in my esteem.
Yeah, absolutely. Marsh overall was a butthead, but he did help Native Americans.
The paleontologist
when they
field
weren't
isn't
getting
now to
their
what we
food rations,
understand.
you know, basically
On the contrary, we
prison
stretch our understanding to
reservations
try and
that
take in the
were
universe.
set up at, you know, the last part of the 19th century. It was pretty tough, but Marsh was a good guy, and you know, and poor Cope, you know, spending a little too much time frolicking at some of those forts. You know, he clearly died of syphilis. You know, so it's like, okay, you know, who was it that figured? Oh, Paul Sereno was looking at his skull. Sohoyas came through.
You got to see his skull, right?
Yeah, I'm in the book.
Let's set the stage for
dinosaurs.
that,
I'm holding the skull.
That's
so they don't even talk about Utah Raptor. He came to visit the site. He talks about Jim Kirkland really liked
A real
Cope,
dinosaur?
You know, here he is. You know. Yeah, Cope visited the Gaston Quarry.
So let's set the stage for everybody at home watching. So, just most basic stuff. Back around the after the Civil War here in the U.S., there was this period of like all this exploration and fieldwork going on. There are these two feuding scientists, Othniel Charles Marsh, Edward Drinker Cope. They're the two main combatants in what we often call the Bone Wars. And let's adjust this here, like that. And I don't know, they're just, they named a whole bunch of different dinosaurs here in the U.S. Stegosaurus, Triceratops, Apatosaurus, Diplodocus.
Morosaurus, Nodosaurus. I mean, you know, all the big
on and on. And so at the end of their lives, they had this bitter rivalry. And
it started pretty early when Marsh pointed out that Cope had misplaced the head of Elasmosaurus on the tail and not on the neck. You know,
it's a pretty egregious mistake.
Things happen. You know, you can be polite.
It was a new animal at the time.
Yeah,
so
you
I guess
can be polite about it.
Yeah.
You know, it was a dumb mistake. You know, if you know you don't make a dumb mistake, you're not a human being.
Exactly. Yeah.
Infallibility was not on my dissertation defense.
But so it was Cope who made the mistake, right?
Yeah, Cope, but and Marsh just rubbed it in.
Exactly. Like Cope tried to buy back all the copies of the manuscript. And Marsh like kept a few and distributed them.
Yeah, and they were accusing each other of stealing each other's fossils, and eventually their proxies out in the field started doing that.
Smashing fossils when they had to leave a quarry so the other guy couldn't get to them and stuff like that.
It was serious. And there were major newspaper wars about it later, where literally,
the New York Herald.
Issue after issue, new aspects of the war. It literally, killed aspects of the U.S. Geologic Survey. Because of the legislature, Congress didn't want to support a group with those kind of people in it anymore. It's really sad because Marsh was in charge of paleo for the U.S. Geologic Survey in its formative years.
So at the end of their lives, they both end up kind of penniless and like miserable at the end of their lives, right?
Yeah, I think Marsh had money.
Oh, okay.
Yeah, I mean,
his uncle was extremely wealthy, George Peabody.
I mean, he bought him his PhD. First PhD paleontologist, but it was paid for cash, which no one would do that for me. I'd do it the old-fashioned way. Cope was never a PhD professor. But he published more scientific papers than any other human in history until Spencer Lucas. Published like 2,300 papers.
Holy cow.
And not just on dinosaurs, on salamanders,
fishes,
fish,
reptiles.
And there's a drawing that that's been reprinted of an ichthyosaur. He drew a picture of when he was like 7.
Yeah.
He just had
He was
lots
like a
of
child
skills.
prodigy. Yeah.
Yeah, he was. He was a genius.
Yeah. Anyway, at the end of the Bone Wars, as like a final challenge, as Cope was dying, I think he wrote that he wanted to have his skull preserved and his brain taken out and measured to see if it was larger than Marsh's brain. It was like a challenge that he's like
he also wanted to be the type specimen for Homo sapiens.
Yeah.
But I think the Baron George Cuvier, nixed that first.
Yeah. So anyway, in what year was that? 1991, something like that. Suhoyas came out.
Yeah, it was pretty early in my years.
Yeah.
No, because 91 is pretty much. I'd already announced Utah, right? So he didn't come out on his tour until 92, 93.
Oh, okay, cool.
Yeah, because it was when we were first announcing, and he, and I think Horner was telling him, "Don't worry about it. It's not real." And Horner did. I mean,
saying it's a big Deinonychus.
Yeah, just a big Deinonychus. Nothing special. So that's pretty much why it wasn't mentioned in that book.
Really?
Even though he has a picture of me in the book holding the skull.
Yeah.
That was, it had nothing to do with my paleo that I'd been doing at the time. He came all the way out here to visit us. But
he came out with Cope's skull in a box.
In a box. Yeah. You want to meet Edward Drinker Cope? Huh? Go back up to camp, and he opens this box and lifts it out. And said, "Meet Edward." Meet Eddie.
That's amazing.
Yeah. And there were definitely people at the Philadelphia Academy of Sciences.
They were not happy.
That were not happy that he took this skull of Edward Drinker Cope on a road tour across the country.
And it's all in the book Hunting Dinosaurs by Luis Cihoyos, if you want to check that out, everybody at home.
Yeah, it's a beautiful book. He's a great photographer.
Oh, yeah.
And in recent years, he's been a great champion of whale ecology.
Oh, interesting.
Preventing, the whole thing of the killing, dolphin stuff in Japan.
Yeah.
They bring them in the bay. He's been fighting that for years, and I think they've ended that. And he's a big reason they ended it.
Nice.
But, he's an interesting character and has done, put himself forth to do some good things.
Yeah.
No doubt.
Now, I know we've got some Star Trek fans in the chat for sure. Do you want to talk a little bit about your novel? And
Okay. Well, back when I first announced Utah Raptor, I got a call from this woman, Diane Carey. How do you know those things might have been hers? I said, well, pack hunting. I said, there's a couple sites where they got a number of Deinonychus together relative to Tyrannosaurs. So it looks, there's more Deinonychus than their prey item. And we think, they were hunting this animal and, being bigger than they are, killed a few. We have good evidence of, many wolves getting killed by bison.
Sure,
during, it's a hard way to make them have lunch when half your friends die in the process. But, that happens. Watch who it takes you out to lunch. You may be a decoy. But Diane, we're talking about this stuff, and I'm explaining, it's theoretical. We don't know 100% for sure, but it seems there's some evidence that maybe they were gregarious. And she goes, well, have you ever read a Star Trek novel? No. And so I've written quite a number of them. And I said, oh, cool. Sitting around the campfire, we came up with a scenario. Wouldn't it be funny if like the Gorn, went back in time and prevented the asteroid from hitting the Earth, so the Federation would never be. Humanity would never take center stage in the universe, and the crew has to go back from some way and make the asteroid hit the Earth, and they discover dinosauroids and save the dinosauroids. Because Kirk's such a good guy, and it turns out when they plant them on a different planet, they become the Gorn in a few hundred, 100 million years. So everybody's kumbaya, hugs and kisses, And she goes, wow, that's kind of a neat scenario. You want to do it? I said, sure. Let's do it. So we wrote this novel together.
What was it called?
First Frontier.
First Frontier.
Yeah, original series number 75. You can remember that, 75. Got the entire Star Trek original series. It's 150 now or something. But anyway, There's a picture of Kurt and Spock. Spock, there with their phasers, and a raptor right behind them, ready to rip their heads off. But of course, Spock meets T-Rex. The Bond.
Do the mind meld thing.
Yeah, but they made this group, and they couldn't. The lawyers for Star Trek wouldn't let us use the Gorn, and of course they have silver faceted eyeballs, but they sure changed the Klingons a lot. So it's like that shouldn't be an issue. Make the Gorn. Dinosauroids, because Klingons don't look like Star Trek original series Klingons. Yeah. But now, you can't do that. The Gorn are the Gorn. So Diane invented this group. We call them the Clan Roo. And the Clan Roo are this group of fairly militaristic, dinosauroids. They're not known as dinosauroids, in the Federation universe. They hated the Federation. They thought they should be the power in the universe. And and realizing that in Earth history, this asteroid came and killed all the dinosaurs, and it's because of them that those pesky mammals took over. So they went back and prevent the asteroid from hitting. But at the same time, the Enterprise is testing a new cloaking device. They're trying to perfect. So they're cloaked, and what it does is shield them from the universe. So when time changed, the whole world changed. They didn't. All of a sudden they appear, and all of a sudden, Klingons are running the show, and with the Vulcans, and there's no, humans anyway. There's no Federation. So they're like, oh man, this is not good for us. So they figure out what's going on and go back in time to make the asteroid hit. They find dinosauroids living on Earth at the time. And instead of letting Kurt and Gabe save him, can't do that because he'd already been killed. They already did.
The lawyer said that?
The lawyers, for Paramount. Nope, you can't let those guys, because Kirk has been killed in the last movie, so he can't save an entire race of beings, which is stupid.
But this takes place before his death, right?
Yeah, I mean, it's a Star Trek novel.
I understand that.
If all of a sudden Kirk, gets superpowers and learns to fly, it's a novel. It's a science fiction novel. It doesn't matter that much. But lawyers being lawyers, they wouldn't let us have that ending. So Diane, just throws this thing in the end, like they're leaving the Earth, the asteroid's coming in, all of a sudden they see the shimmering light or something, and the preservers come in and save the Clan Roo's ancestors, put them on a planet, they come to Clan Roo. And it's so interesting because Diane put stuff in there. I didn't get to edit every bit of it. She's the main author. I wrote the T-Rex versus Alamosaurus scene.
Nice.
So I wrote the scene where Spock meets T-Rex. Had to be done. But she throws in this ending. She talks about the Clan Roo that some of the Clan Roo cut off their tails to be better in a spaceship. It's like they wouldn't do that. It's like anchors. Ankles are caudifemoralis muscle. That's part of their body. They would not be cutting their tails off. And evolutionarily, maybe the tails are shortened, but it's still going to be the anchor point
for the caudifemoralis.
For those muscles.
Swinging
mammals aren't that way. You're thinking, you don't
Too
know.
human centric.
Yeah. But she just throws in this thing. The preservers come down and save the Clan Roo over. It was like, flipping a switch ending for her. We had a good ending. It's like, this ending sucks. I was so upset with the ending of the book, but that was the compromise she came up with the lawyers, and she had to deal. She goes, you got to deal with the Paramount lawyers every time you write a novel using Star Trek characters. They can tell you where to go.
I mean, for a lot of people, this is like a holy writ. It's like every time there's some piece of new Star Trek media, it's I don't know a lot about Star Trek, but it's...
Well, we could have done a good job because we certainly didn't want to hurt the franchise. It's like, this didn't hurt the franchise. But, what do you do? Lawyers are lawyers. They got to keep busy, make look like they should be earning their money. Certainly make more money than me.
Yeah, shoot. Don't become a paleontologist if you want to get rich, everybody.
But being a paleontologist, if you're already rich, works pretty well for some people. There's a number of them that are born rich or paleontologists, and they don't worry about a job. Just hang out with an institution.
Sounds nice. Shoot.
I mean, Nathan Merval's into many things.
I've worked on some stuff with him.
His gastric, his cookbook, the Bible of
Yeah.
gastronomy, molecular gastronomy.
Uh-huh.
It's like one of the Bibles ever published on the tip.
Yeah.
It's like, how did you crank that out? In any kind of time frame.
He's a really interesting guy.
Yeah, he's brilliant.
Yeah.
He's a brilliant guy. There's no doubt about it.
And then the diplotacid tail lip thing.
Going hypersonic.
Very, very cool. Do you have any views on that?
I'm not against it.
Yeah. It's crazy to think about like a flesh and bone structure being able to do what a bullwhip does. Mm-hmm. But
it's more like a long chain of nunchucks.
Yeah.
But you can calculate how these things would turn and how they'd be accelerating.
Uh-huh.
And the calculations, it's not a continuity. It's not like you're going to use integrate the tail to come up with that number.
Sure.
You actually work in discrete segments.
Uh-huh.
Basically integration is making more and more segments until you get to like minute, and that's how you do these curved type of things.
Uh-huh.
That's why they make us take advanced calculus to be paleontologists. But I did. I went to the school of mine, so like unlike most paleontologists, I had 3 semesters of calculus before I could take my elective math course,
uh-huh.
and statistics and probability.
Uh-huh.
Oh man! But it's what he did was real valid mathematics and not that complicated.
Yeah.
If you're a mathematician, my buddy Dave Thomas probably could have pulled that off real well.
Yeah.
First guy I ever dug dinosaurs with.
Huh.
And first year of grad school, he had a cover story in Scientific American.
Wow.
Invented non-reversing mirrors.
Uh-huh.
Discovered in the bathtub that bubbles that are in the shape of a hyperbolic paraboloid are non-reflecting. So the light comes in and goes around and comes out. So you look at the image, and when you're centered on it, big enough one, you lift this hand, the mirror lifts this hand.
Uh-huh.
So it
non-reversing. Really strange.
It goes through and comes out.
That's
and it
wild.
turns out that, and it's being used, in different technologies.
Yeah.
If you want to beam a laser into something, and they do it with prisms, but you can also do it with this kind of a surface. They have it come back, so you can build up, power and stuff.
Yeah.
It's a pretty neat technology. But yeah, cover story in Scientific American, when he's like 22,
That's incredible, yeah.
Dave's a pretty bright guy.
Yeah. Very cool. And first guy you dug dinosaurs with?
Yeah, his dad, was a pretty famous sculptor. He did this globe of the earth.
Uh-huh.
Prehistoric horrors.
10 feet.
What's all this archaic anatomy?
Pretty big.
Yeah.
And he did it totally to scale. And he built the rig. So he had this big circular thing out, with a little thing that would come down. So he built all the mountain ranges and things on this globe to scale.
Very cool. And it's also got the equator slightly bulged out.
Oh yeah, totally.
All the scale, yeah.
Correct.
Nice.
He worked on it for several years, but he also is famous for some of his sculptures, the 2 bronzes in front of the New Mexico Museum. The Albertosaurus and the Pentaceratops. He sculpted both of those bronzes.
Cool. Yeah.
He was a well-known artist, but he was very much a jack of all trades. And he was good friends with Jim Madsen, the first Utah State paleontologist. So when I was going out with them as a young punk, kid, not knowing what I was doing, those guys taught me how to dig a dinosaur. And who would have believed, I didn't meet Jim much. I did meet Jim once during that time interval.
Sure.
But I ended up taking his job, replacing him as the 3rd state paleontologist.
Pretty cool. I mean, the amount of work you've been able to do in this job is incredible. I don't know. I know you haven't had grad students or anything because that's not the kind of.
Well, I've been on graduate committees.
Oh yeah.
People in various countries and various states.
But your impact on the field is inestimable. I mean,
I've been real lucky. I mean, there's no question. And fortunately, I got the tools of the trade. That allowed me to take advantage. People could have looked at that thing in the rock shop, or just said, well, these guys are commercial, deal, and I'm not going to talk to them.
Yeah.
And the fact that I went up and said, oh, man, where'd you get these? Opened the doors and, really set the views for this whole thing. And my connections with Rob got Rob into casting and molding, and now he's one of the, foremost guys. Got exhibits in the Carnegie Museum and, exhibits all over the place. When I was in Osaka, all these dinosaurs that I've named that Rob Gaston has done replica mounts of. We're all in this museum in Osaka, so I'm like, well, here's Gastonia, here's Falcarius, here's Utahraptor, all my babies, and it's like, there are more of my dinosaurs in this museum than Japanese dinosaurs. And it's just because Rob sells things cheaper than anybody else.
Yeah.
You get these really good mounts, for a quarter of what you get them from research casting or, Treebold. They do good work. I'm not saying they don't do good work.
do wonderful work. But it's
they're
pricey.
very pricey compared to Rob.
Yeah.
But money's not the purpose. Rob, he loves trying to figure out how to mount a new dinosaur. And how to fix bones that are broken. He casts the original stuff, and then he modifies the cast. So he also has a set of molds that think of as research molds. So if you want the Zuniceratops stuff, as it came out of the ground, he's got a set of everything for you.
Very cool. Very cool.
Or you can see where he's fixed broken or distorted bones and made the perfect skull out of it.
Yeah.
But he does very well. I'm probably going to say goodbye as you tip over in this breeze. Maybe he's going to say that.
I've got the rock there.
You got a rock on it. Okay.
Yeah. Is it about time to wrap things up, you think?
I don't know. It's whatever. I'm actually comfortable. Are you hot?
I'm not.
No, it's
I'm getting a little hungry, but this is great.
I know. We'll go have lunch when we're walking away from here. What time is this?
It's 2:21 right now.
No, you're kidding.
No, I know, right? Flew by. Yeah.
No. It's pretty good. It's like with the Gaming Beaver. That seemed like the last 5 minutes. Yeah, look up the Gaming Beaver Kirkland dinosaurs.
He's probably on Twitch too, actually. He's
probably
a big name, right?
I mean, he's got a following.
Yeah.
You put that thing up in first day, 300,000 views. What the heck?
I'm not anywhere near there yet.
300,000 views.
We've got 217 people watching right now, which is pretty good.
Yeah, that's not bad.
Yeah, for a live broadcast. Not too bad.
And this is ground zero for new discoveries. Everything we find here is a new dinosaur.
I wish I could have done
name
some
out of that quarry, but I got 3 more Ankylosaurs to name.
Very nice.
Put the cherry on my professional cake. I still wish I could find a Middle Jurassic site, because that would be the big cherry. I'd be dropping the watermelon on my creative cake. And no, we got
Middle
the first terrestrial fossil out of the Middle Jurassic in North Dakota, the United States.
Really?
Yeah, it's a big conifer branch, but
okay, it's better than nothing.
It's better than nothing. It's pretty cool. But anyway, let your people.
And if dinosaurs had not died, I imagine the
we can wrap it up.
Still be small
just before we do,
like
any advice for aspiring paleontologists? Maybe there's a young person watching this right now, and maybe they're just kind of realizing that science can be interesting.
Well, one of the things I tell kids all the time is write. Keep a naturalist notebook, because what do I do more than anything else? I'm very dyslexic, not as dyslexic as Jack, but I'm pretty dyslexic. Is you got to write, because nothing counts unless you publish it. And writing. Naturalists observe the world around you. The present is the key to the past. So as a kid, record what you see in your backyard. Record what the bugs are doing. Just write things, draw sketches in it, but work on writing, because you will write more than anything else as a paleontologist. You got to write proposals to get money. You got to write, letters and things to convince people to communicate with other scientists. With email, we do a lot more shorthand communication, but still communication is mostly with the written word. And it's of vital importance.
It's like a muscle you got to exercise.
And the more you write, the better you write. And the more you sketch, the better you sketch. And drawing pictures of things, distill objects that are complicated, so they're just these, vertebrae, complete bizarre shape. When you draw the shapes, all of a sudden you realize you're distilling it to the most important parts of that shape, and you learn it better. And about the only class in science where they have you draw pictures is some of the biology instructors will have you look down a microscope, draw a picture of what you're seeing there. That is, this is why we keep notes. Keeping notes, writing as we listen. We have multiple senses to put it into our brain permanently. And, I can't emphasize, don't teach kids how to learn in school. And this is why we should encourage kids to take notes. In high school, you don't even have to look at your notes. Just the process of doing it makes you learn better of what
It's
you're
in
doing.
your brain, yeah.
And drawing pictures of bones, you go to museums, draw a sketch of that one. Oh, now I see how this vertebra is different from this one. You know, you look at two pictures, it may be tougher to do, but when you draw a picture of both, sudden, oh, clearly that's the thing that makes it different. But then, you know, geology, there's not a course in school that's not going to help you. You say, well, what good civics? Well, you may need to talk someone into preserving a place like this. You may need to talk to your congressman about preserving places, you know, or dealing with a political reality. You know, it's like, you know, there's nothing you learn that can't be applied to paleontology.
I like that.
And no one, as individuals, don't have something they can contribute to paleontology. You know, I mean, you can be a complete amateur. I am a lawyer. Well, there are times where a lawyer might get us access to a site.
100%.
You know, or I have this skill, or I'm a good fundraiser. Oh, our museum sure could use someone to help us raise money for this project. You know, I'm a good artist, or I'm a good photographer. Or I know how to weld. Oh, you can help us mount the skeleton. And there is no human endeavor that can't be used to forward paleontology.
I like that. I think that's a great place to end.
All right.
Thanks, Jim. Let's see. At the end of these broadcasts, I try and do what we call a raid, where we take everybody from here, put them into another channel, and it helps other people find our channel and that kind of thing. So I'm going to look for somebody real quick that we can raid. Let's see. Let's go ahead and do...
Interesting. I'm learning something.
Yeah. This is a cool platform. There's stuff on here.
I've never even heard of this platform before.
Yeah. Let's see here. Let's go ahead and raid into...
Check out The Living Planet on YouTube.
The Living Past. That's the Ethan's channel. Yeah.
It's really worth it.
Yeah, good stuff. Let's go ahead and raid Turtles and Chill. They've just got a camera trained on a tank of red-eared slider turtles all day. So it's a place where people can hang out and study and that kind of thing. And it's fun. So, but yeah, there's bird watching ones. There's all kinds of cool stuff that you could probably get into just to put on in the background while you're working. Let's see. Raid.
See, I'm an old fart and he's a young fart, so he can do more of this stuff.
Yeah. Let's see if that works. There we go. Yeah.
Just to make it better for young, aspiring paleontologists.
No, I appreciate it more than you know, Jim. Holy cow! This has been a great past 2 weeks, and I'm looking forward to the next week here before I go back home to California. And it's been awesome.
Yeah, well, you got to come back because there's a lot of stuff to be done out here.
We've got those projects. Never been there, no.
Oh man,
to our own existence.
Almost all my fieldwork's been up in Montana. So
no, there's a lot of different things. Hopefully Mexico will be clear because I've got all those years in Mexico, man.
I'd love to go down there.
Amazing stuff. Some of the most fossiliferous stuff I've ever been in my life.
Anyway, everybody, thank you again so much for watching. Thank you for your support. I'll see you soon, hopefully. Yeah, thank you, Jim. Really, really appreciate this. It's been wonderful. Everybody really enjoyed this. So.
Good, I'm glad.
Yeah. All right. Bye-bye, everybody. Take care. All right, there we go. And let me go ahead and close down the broadcast after the raid.